Sir, sir, good morning. Namaste. Sir, from Bombay, sir.
Yes,
Thank you,
I'm
thank you.
at the airport.
Welcome. Sir, sir, good morning. Namaste. Sir, from Bombay, sir.
Yes,
Thank you,
I'm
thank you.
at the airport.
Welcome. Sir, sir, good morning.
Good morning, everyone. Maths is the language of the universe, so is the more equations you know, the more you can converse with the concepts. It is my absolute pleasure to welcome all of you to today's exciting event. We are gathered here to explore the fascinating world of
Sir, from
numbers,
Bombay, sir.
patterns, and problem solving. Let us
Yes.
start this fabulous session with Tamil Taiwal. Let us
Yes.
start this fabulous. Thank you. Mathematics reveals its secrets only to those who approach it with pure love for its own beauty. Now I call upon Dr. M. Kritika, HOD, Department of Mathematics from Suguna class to give the welcome address. This fabulous Mathematics
Good morning,
reveals its
everyone.
secrets
It is
only
my
to
great
those
pleasure
who
to
approach it
welcome you
with
all
pure
to
love
the National
for its
Virtual
own
Conference
beauty. Now I
on
call upon
Recent
Dr.
Trends in
M.
Pure
Kritika,
and Applied
HOD,
Mathematics,
Department of Mathematics
taking place
from
here in
Suguna class
Suguna
to
College
give
of
the
Arts
welcome
and
address.
Science. As mathematicians, we are all passionate about beauty,
Mathematics
elegance,
reveals
and
its
importance
secrets
of
only to
mathematics
those who
in our
approach it
world
with pure
today.
love for its
This
own
conference
beauty.
brings
Now I
together
call upon
recent
Dr. M.
experts
Kritika,
and
HOD,
enthusiasts
Department of
from
Mathematics
around the
from
globe to
Suguna
share
class to
their
give the welcome
latest
address.
research. As mathematicians, we are all passionate about beauty,
Mathematics
elegance,
reveals
and
its
importance. We have
secrets
an
only
excellent
to those
program
who
lined up
approach
for
it
you
with
today,
pure love
featuring
for its
keynote
own
lectures,
beauty.
extraordinary research experts, and enthusiasts from a wide range of fields to share their from pure mathematics to applied mathematics. We are all passionate. Our conference theme, recent trends in pure and applied mathematics, reflects the importance of mathematics in addressing some of the world's most pressing challenges from climate change and sustainability to health and finance. This conference is not just about sharing knowledge. It is also about productive collaboration of building meaningful solutions. Some of the world's before we begin, I would like to extend a special welcome to our President Ma'am Suguna ma'am, whose visionary leadership has been instrumental in shaping our college into the esteemed institution. I also warmly welcome our chairman, Shri Lakshmi Narayan Swami sir, from your dedication to your unwavering commitment to providing quality education and for laying the foundations for shaping our college, our secretary, Dr. Srikanth Kannan sir, and I also warmly welcome V. Shekhar sir, how provide invaluable guidance and expertise. I warmly welcome them. I also welcome our beloved principal, Dr. Srikanth Kannan sir, for your dedication to Dr. Srikanth Kannan sir, and well-being and truly V. Shekhar sir. I would like to extend my sincere appreciation to our plenary speakers as well as our management and volunteers, without whom this conference would not have been possible. Once again, welcome to the National Visitor Conference. Recent I would like to extend my sincere appreciation to our plenary to have us here and look forward to a futuristic and productive conference. This conference would not have been possible. Once again, welcome to the National Visitor Conference. Recent I would like to extend my sincere appreciation to our plenary to have us here and look forward to a futuristic and productive conference. This conference would not have been possible. Once again, welcome to the National Visitor Conference. Recent I would like to extend my sincere
Distinguished members of the audience, at the outset, I bring you greetings from our chairman and first lady, Sri Lakshmi Narayan Swami and Suguna, by expressing their interest, their appreciation for the manner in which you have been distinguished members of the audience, the greatness of the subject from our chairman and first lady, Sri Lakshmi Narayan Swami and Suguna, college, in our educational institutions. By expressing their interest along with their appreciation for the manner in which you have been distinguished members of the audience, that could go a great way in the great value of the subject from our chairman and first lady. I also have great pleasure in educational institutions by expressing their greeting our director for the manner in which you have been distinguished members of the audience, that could go a great value of the Dr. Rajkumar. I also have great pleasure. He's been doing a wonderful job on this. I've been watching over the last 2 weeks. Director all the other staff members, Dr. Renuka, and all Dr. Rajkumar. It's so nice that you have been able to talk in experts from all the 3 states, Kerala, Karnataka, and Gujarat, to be resource persons on all the other programs. Mathematics has been and all Dr. Rajkumar. It's so nice that you have been able to talk in all the experts from all the 3 states, Kerala, Karnataka, a big thing called Vedic mathematics, to be resource persons on all the other programs. Mathematics has been going to be the most relevant and all in the pure and applied mathematics. It's so nice that you have been able to talk in all the experts from all the 3 states, Kerala, Karnataka, a big thing called very valuable addition to be resource persons. It is because of the sense of appreciation that even though I am far away from you, we are going to be the most relevant and all in the pure and applied mathematics. It's so nice that you have been able to pure and applied experts, Vedas, gratitude, inspiration, and love for this thing called very valuable addition. I hope we can pray that all of the departments will take over from you, emulate this kind of programs. I wish the program all success. God bless.
Thank you, sir, for your inspiring and thought-provoking address.
I hope we can pray that all of the departments will take over from you, emulate this
On
kind
behalf
of
of everyone
programs.
here today,
I
I
wish
would
the
like to
program
extend
all
our
success.
deepest
God
gratitude
bless.
to Dr. V. Shekhar for his tireless efforts and dedication to the Thank you, sir, for inspiring and thought-provoking and not only social leadership and excellence of communication, but also inclusive role. On behalf of everyone here today, I would like to extend our deepest gratitude to Dr. V. Shekhar for his tireless efforts and dedication to the Thank you, sir, for inspiring and thought-provoking and not only social leadership and excellence of communication, but also inclusive role. On behalf of everyone here today, I would like to extend our deepest gratitude to Dr. V. Shekhar for his tireless efforts and dedication to the Thank you, sir, for inspiring and beyond poetry, I'm not only activism, leadership, excellence is my passion, but also contribution to the world. On behalf of everyone here from I would like to take my celebrations for the Dr. V. Sir for his tireless efforts in education. And the more, despite beyond poetry, I'm not only activism, leadership, excellence is my passion, but also contribution to the world. On behalf of everyone here from I would like to take my celebrations for the Dr. V. Sir for his tireless efforts in education. And the more, despite beyond poetry, I'm not only activism, leadership, excellence is my passion, but also contribution to the world. On behalf of everyone here from I would like to take my celebrations for the Dr. V. Sir for his tireless efforts in
Every year, 150 education. We're also doing an art college and every year, reward every company excellent in quality and quantity. Education always keep in mind. We're also working on art college and Suguna pumps and motors. They're using it for last 65 years. Very working from the point of view. Looking at years of pumps and motors. Reward always every company excellent in quality and quantity. We are in education always keep in mind. And also working on every point and Suguna pumps and motors. They're using it for last 65 years. Very working from the point of view. Immense pleasure. Have reward one program company active program like this. Quality and quantity. Going online. I'm very happy that export from different states, Indian states, Kerala, Karnataka, Andhra, exports are launching this kind of annual conference. Very heartening to know that one more program company, this kind of program like this, rapid conference will always be online. I'm very happy students export from develop their skills, particularly in the field of Kerala, Karnataka. Today's topic is also export topics, urban trends in poor and apprenticeship. It's very heartening to know that it's very essential. This kind of program like this, basically, if you know mathematics, you can very well affect there in computer science, skills, AI, particularly in the field of Kerala, Karnataka. Ultimately, this is only going to help urban trends in poor and apprenticeship. If you are successful in maths, it's very essential. Successful every kind of program like this. Basically, if you know mathematics, basic quality for an Indian, very well affect there has no mathematical skills, AI, then only if you can Kerala, Karnataka. Ultimately, this is only going to help urban trends in poor and apprenticeship. I extend if you are successful in maths, all the best for successful every national conference. Basically, if you know mathematics, quality for an Indian, full-day conference, there has no mathematical to benefit out of this, then only if you can Kerala. For the 100 students will be qualified to enjoy this I extend successful in maths, all the best for successful every national conference, and all will be given the certificate. Quality for an Indian, this program conference, there has no mathematical to benefit out of this, faculties, the development students will be qualified to enjoy this applied mathematics. I extend successful in maths, all the best for successful conference, and all will be given the certificate to join with us. Also, program conference, we like our entire mathematics of this department, the development program, all the best. God bless everyone. Thank you so much. All the
Thank you, sir, for your inspiring and provoking press. Your vision, leadership, and dedication to our institution are truly commendable. Now I call upon Assistant Professor, Department of Mathematics, Suguna College, Dr. G. Menaka, to give the introduction speech about our certificates. Thank you, sir, for your inspiring and provoking press. Your vision, leadership, and dedication to our institution are truly commendable. Our chief now I call upon Assistant Professor, Department of Mathematics, Suguna College, Dr. G. Menaka, today give the introduction speech about our certificates. Thank you, sir, for your inspiring and provoking press. Your vision, leadership, and dedication to our institution are truly commendable. Our chief
MPhil and PhD coaching in University of Science and Technology. He has his areas of research interest in ecology, gas theory, complex and linear dynamic testing, signal processing, information theory, completed his quantum physics. He has done his research publication, MPhil and PhD coaching in University of Science and Technology. He has his areas of research interest in Rajagiri School of Engineering Complex and linear dynamic American mathematical processing, information theory, completed his quantum difference equation. He has National Association of Engineers, MPhil and PhD coaching in University of Kerala and Technology. He has his areas of research interest in He has organized major international and American mathematical processing, information dynamics, analytics, quantum intelligence. He has data science, number theory, and mathematics from Kerala and Technology. He has applications. He has established he has organized major international and research in the areas of psychology, dynamics, analytics, quantum intelligence. He has data science, number theory, and mathematics from Kerala and Technology. He has applications. He has
Thank you, ma'am. Let us welcome our chief guest to take over the rightful seat.
research in the areas of psychology, dynamics, analytics, quantum intelligence. He has data
Thank you for the nice introduction. Am I audible?
Yes, sir. Thank you, ma'am. Let us welcome our chief guest to
First
take
of all, let
over
me
the
thank the
rightful seat.
organizer, in particular Dr. Pratibha, for inviting me to give a talk. Thank you for the nice introduction. Am I audible? Can I share this
Yes,
slide?
sir. Thank you, ma'am. Let us welcome our chief guest to
First of
take
all, let
over
me
the
thank the
rightful seat.
organizer,
Yes, sir, you can
in
present.
particular Dr. Pratibha, for inviting me to give a talk. Thank you for the nice introduction. Am I audible? Can I share this
Yes,
slide?
sir. Thank you, ma'am. Let us welcome our chief guest to
First of
take
all, let
over
me
the
thank the
rightful seat.
organizer,
Yes, sir, you can present.
for inviting me to give a talk. Thank you for the nice introduction. Am I is it visible? Can I share this
Yes,
slide?
sir. Thank you, ma'am.
Yes, sir.
Let us welcome our chief guest to
First of
take
all, let
over
me
the
thank the
rightful seat.
organizer,
Yes, sir, you can
in
present.
particular Dr. Pratibha, for inviting me to give a talk. Thank you for the nice introduction. Am I is it visible? Can I share this
Yes,
slide?
sir. Thank you, ma'am.
Yes, sir.
Let us welcome our chief guest to
First of
take
all, let
over
me
the
thank the
rightful seat.
Yes, sir, you can proceed,
Yes, sir, you
sir.
can present.
Dr. Pratibha, for inviting me to give a talk. Thank you for the nice introduction. Am I is it visible? Can I share this
Yes,
slide?
sir. Thank you, ma'am.
Yes, sir.
Let us welcome our chief guest to
First of
take
all, let
over
me
the
thank the
rightful seat.
Yes, sir, you can proceed,
Yes, sir, you
sir.
can
I would
present.
like for inviting me yeah to give a talk. Thank you for the I would like nice introduction. Am I is it visible? Can I share this
Yes,
slide?
sir.
Data
Thank you, ma'am.
Yes, sir.
Let us
and
welcome our chief guest to
first of
take
all, let
over
me
the
thank
rightful
the
seat.
Yes, sir, you can proceed,
Yes, sir,
sir.
you can
I would
present.
like for inviting me as far as yeah to give a talk. Thank you for the I would like nice introduction. Am I
Many of the
visible?
students are concerned
Share this
Yes,
slide.
sir.
Data
Thank you, ma'am.
Yes, sir.
Let us
and
welcome our chief guest to take over the rightful
topology is
seat.
an
Yes, sir, you can proceed,
Yes, sir,
sir.
you can
I would
present.
like
for inviting me
as far as
yeah to give a talk. Thank you for the
I would like when they
nice
study
introduction. Am I
many of
visible?
the students are concerned
Share this
Yes,
slide.
sir.
Data
Thank you, ma'am.
Yes,
they
sir.
may not
Let us
find and
welcome our chief guest to take
let
over
me
the
thank
rightful
the
many
seat.
Yes, sir, you
applications
can proceed,
Yes, sir,
sir.
you can
I would
present.
like of topology
inviting me
as far as
yeah
or what they study.
thank you for the
I would like when they
nice
study
introduction. Am I
many of
visible?
but nowadays it is not
Share this
Yes,
slide.
sir.
Data
Thank you, ma'am.
Yes,
they
sir.
may not
Let us
find and
welcome our chief guest to take over the
as
rightful
there are
seat.
many
Yes, sir, you
applications
can proceed,
Yes, sir,
sir.
you can
I would
present.
plenty of data of topology
inviting me
as far as wherever or what they study.
thank you for the
I would like when they
nice
study go we can find that
introduction.
but nowadays it is not so.
Share this
Yes,
slide.
sir.
that is abundant, has the air. Plenty of that there is. Wherever we want whenever you want to go, we can find that. But nowadays it is not so. That is abundant, has the air. Plenty of that there is. Wherever we want to choose. Plenty of that use three main disciplines of
Excuse me, sir. Sir,
mathematics.
your voice is not clear. I think please check your network connection, sir.
That can be used when three main data analytics and analyze the 10 to 12 years.
Excuse me, sir.
Sheet.
Sir, your voice is not clear. I
This
think
is the
please check your network connection, sir.
that can be used when three main data analytics and analyze the 10 to 12 years.
Excuse me, sir.
Sheet.
Sir, your voice is not clear. I think please check your network connection, sir.
That clear now? Am I used when three main data? Am I audible? 10 to 12 years.
Excuse me, sir. Sir, your voice is not clear. Sir, your voice is not clear, sir. Network connection, sir.
That clear now? Am I used? Check, let me check. Am I audible? 10 to 12 years.
Excuse me, sir. Sir, your voice is not clear. Sir, your voice is not clear, sir. Network connection, sir.
That clear now? Am I used? Check, let me check. Am I audible? 10 to 12 years.
Excuse me, sir. Sir, your voice is not clear. Sir, your voice is not clear, sir. Network connection, sir.
Clear now? Clear now? Am I used? Check, let me check. Am I audible?
Yes, sir. Excuse me, sir. Sir, your voice is not clear. Sir, your voice is not clear, sir.
I'll continue.
Network connection, sir.
Clear now? Clear now? This is the next step. Let me check. Am I audible? Sample of
Yes, sir. Excuse me, sir.
another point cloud.
Sir, your voice is not clear. Sir, your voice is not clear, sir.
I'll continue.
Network connection, sir.
Clear now? Clear now? Which is this is the next step. Let me check. Am I audible? Sample of
Yes, sir. Excuse me, sir.
another point cloud.
Sir, your voice is not clear. Sir, your voice is not clear, sir.
I'll continue.
Network
The
connection,
MRI is clear now? Clear now? Page which is this is the next step. Let me check. Is projected in three dimension
yes, sir. Excuse me,
plane
sir.
as a point cloud.
Sir, your voice is not clear. Sir, your voice is not clear, sir.
I'll continue. The MRI is clear. This is an example page which is this is the next step. Let me check. Taken from is projected in three dimension
Yes, sir. Excuse me,
plane
sir.
as a point cloud.
Sir, your voice is not clear. Sir, your voice is not clear, sir.
I'll continue. The MRI is clear. This is an example page which is this is the next step. Let me check. Taken from various flights.
Yes, sir.
Flights at a particular instant of time.
Your voice is not clear. Sir, your voice is not clear, sir.
I'll continue. This is again a point cloud. This is an example page which is this is the next step. Let me check. Taken from various flights.
Yes, sir.
Flights at a particular instant of time.
Your voice is not clear. Sir, your voice is not clear, sir.
I'll continue. This is again a point cloud. This is an example page which is point. This is the next step. Let me check. Taken from various flights. A collection of points considered at a particular instant of time. Two-dimensional plane.
Not clear. Sir, your voice is not clear, sir.
I'll continue. This is again a point cloud. But this point cloud, which is point, various flights, a collection of points considered at a particular instant of time. Two-dimensional plane.
Not clear. Sir,
The next instant,
not clear, sir.
I'll continue. This is again a point cloud. This point cloud may vary because various flights, a collection of points, some flights will be landed at a particular instant of time. Two-dimensional plane. Some will take off from some other. The next instant position I'll continue. This is a 5-point cloud. So this point, but a non-point cloud. This cloud may vary because various stationary point clouds, a collection of points, some flights will be landed at a particular instant of time, two-dimensional place. Some will take off. This is some of the next instant position. Example of it. This is a 5-point cloud. Time. This point, but a non-point cloud. This cloud may vary. An example of stationary point cloud. A collection of points, some flights will be landed, which can be regarded as a time series. Some will take off. This one is position. Example of EEG. Time. This point, but a non, again a time series. This cloud may vary. An example of stationary point is an altitude where such a cube has some which can be regarded as a time series. This is a particular two-dimensional image. This one is totally in a position. EEG. Time. This point, but a non, again a time series. This cloud may vary. An example of stationary point is an altitude where such a cube has some which can be regarded as a time series. This is a particular two-dimensional image. This one is totally in a position. EEG. Time. This point, but a non, again a time series. This cloud may vary. An example of stationary point is an altitude where such a cube has some which can be regarded as a time series. This is a particular two-dimensional image. This one is totally in a position. EEG. Time. This point, but a non, again a time series. This cloud may vary. An example of stationary point is an altitude where such a cube has some which can be regarded as a time series. This is a particular two-dimensional image. This one is totally in a position. EEG. Time. This point, but a non, again a time series. This cloud may vary. An example. An example. An example. Hope the slides are visible. Slides are visible. Okay. Hope the slides are visible. Slides are visible.
Yeah, visible, sir.
Okay. Hope the slides are visible. So this is slides are visible. An example of a framework. Some changes.
Yeah, visible,
so
sir.
This is a non-stationary network. Hope the slides are visible. So this is slides are visible. An example of a framework. Some changes.
Yeah, visible,
so
sir.
This is a non-stationary network. Hope the slides are visible. So this is slides are visible. An example of a framework. Some changes.
Sir, please on your microphone, sir.
Hope the slides are visible. So this is slides are visible. An example of a framework. Some changes.
Sir, please on your microphone, sir.
Hope the slides are visible. So this is slides are visible. An example of a framework. Some changes.
Sir, please on your microphone, sir.
Hope the slides are visible. So this is slides are visible. An example of a framework. Some changes.
Sir, please on your microphone.
Can you hear me? Hope the slides are visible. So
Yes, sir. Now it's clear only.
this is slides are visible. An example of a framework. Some changes.
Sir, please on your microphone.
Can you hear me? Hope the slides are visible. So if you look at
Yes, sir.
this
Now
point
it's
cloud,
clear only.
Hope you can see the slides and audible. I am audible, right?
Sir, please on your microphone.
Can you hear me?
Yes, sir, audible, sir.
Okay, thank you. So this is, so if you look at
Yes, sir,
a
now
set
it's
of
clear
data
only.
with the leftmost one, we can audible, I am audible, right? Second one is like clusters, third one is like a loop, and the fourth one
Sir, please
is,
on your
can you hear me?
Yes, sir,
White
audible,
shape.
sir.
Okay, thank you. So this is, so if you look at
Yes, sir,
a
now
set
it's
of
clear
data
only.
with every data has a shape, we can audible and shape conveys a meaning. Second one is like clusters, statement given by Gunnar Carlson, and the fourth one
Sir,
is,
please on your
can you hear me?
Yes, sir,
White
audible,
shape.
sir.
Okay, thank you. Originated this. So this is topological data analysis.
Yes, sir,
A
now
set
it's
of
clear
data,
only.
space of data is a shape. We can audible and shape conveys a meaning. Second one is like clusters, space given by Gunnar Carlson, and assign distance. The concept of distance. Can you hear me? Space of data is a metric space. Originated this. For example, this is topological data analysis. These two images,
Yes, sir,
a
now
set
it's
of
clear
data,
only.
two different black and white data is a shape. We can audible and shape conveys a meaning. These two images, that space which is that's not the Euclidean distance. The concept of distance. But get find space of data is a metric. Find the distance between these two images. For example, this is what we do. Two images. Assign one for white and different black and black. Assign one for white and zero for black. Look at the first image. That's not the Euclidean distance. I can encode that space of data is 1 1 0 0 1 1 1 1. What we do? The corresponding first row in the second image black 1 1 1 1 0 0 1 1 1 1. Look at the first image. First row. So the distance between them is 0. Encode that change space of data is in the coding. Look at the second row. What we do? Again, second row is same for both. First row to third row. 1 1 first image 0 0 1 third row can be encoded as same. 1 0. So the distance between them is 1 1 1 0 0. So 0 1 in the coding. And for the second image, third row is 1 0 0 0 first row to third row and finally 1. So if you look at third row, the encoded can be encoded as binaries bits. So they change in 6 1 1 0 0. So the distance between the coding. And for the second row, third row in the first picture 1 0 0 for the second image, first row is 6 0 and finally 1. Similarly, you can find the third, if you look at the third row, the encoded row in the binary and fourth row in the second image. They change in 6 so similarly find the distance between the coding. Take the maximum row, third row in the first picture, 1 0 0 for the second image, first row is 6 0. There is a way to find, similarly you can find the third image. Look at the third row, the encoded row. How do you find distance between binary and fourth row in the second image? There are many ways. So similarly find the distance any point T on the maximum row, third row in the first and G of T. So find the more distance between them. This will be a G of T. More effective minus G of T. Find distance between find effective minus G of T. There are many modulus for every T on the x-axis T on the x-axis minimum of all them. That is again a distance. And G of T between two signals. So find the more distance between them. This will be a G of T. In the Euclidean plane R2, there are many types of distance other than our Euclidean distance. On the x-axis, Euclidean distance we know distance between 2 points. Say x1 y1 and x2 y2 is root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Euclidean plane another distance between x1 y1 and x2 y2 is maximum of more x1 minus x2 and more y1 minus y2. Another distance is say x1 y1 and x2 y2 x2 plus is more y1 minus y2. So these are the y1 minus y2 the whole square. Some other forms of distance other than the Euclidean distance between x1 y1 and x2 y2 is max topology originated due to Königsberg-Birch problem. x2 plus is more y1 minus y2. Königsberg-Birch problem is some other form other than the Euclidean distance. That between x1 y1 and x2 y2 there are 4 islands and 7 bridges. One has two islands, 2 shores and 7 bridges. One has to start from one location, go through Königsberg, all the bridges is exactly one and come back to the original position, visiting all the places. There are, is it possible or not? Islands and 7 bridges. The problem is start from say C, go to B, go to A, go to D, and finally come back to C. But one location, the answer is negative. It's not possible, as explained by Leonard Euler. Exactly one. So this is an example of a data analysis. The real practical problem is converted into a mathematical problem. The graph-theoretic problem, go to B, and from to A, go to the solution of the mathematical problem, we are solving a real problem. It's not possible. So in topology data analysis, we apply topology, so develop tools to visualize data and for studying quality features of data. So mathematical problem, as we all know in topology, we study the topological properties of objects. What are topological properties of objects? Properties which are invariant under isometries, mathematical problem, stretching, shrinking, bending, blowing, or by continuous transformation. If we can do one way and visualize inverse continuously, such a transformation is called a topological transformation or a homeomorphism. As we all know in topology, for example, a sphere with a handle, topological properties of objects is topologically same as a torus. Properties which are invariant under a teacup is topologically same as a donut, shrinking, bending, blowing, or by continuous transformation. A sphere, if we can do one way, topologically same as an ellipse or inverse, but a sphere is not topologically same as a torus transformation or a homeomorphism. As we all know in topology, there is one hole in the torus with a handle. In sphere there are no holes outside. Topologically same as a torus. So continuous deformation, a teacup, if we can continuously deform one object to another object, then we say that they are topologically same. And the other way also. If we can do one way, topologically same as an ellipse is topologically same as a square. Here is not topologically same as. In the second row you can find topologically because all the objects are topologically. There is one hole in the torus with a handle. In sphere there are no holes outside. The letters A, B, D, E, O, P, Q. So continuous deformation is same. They are homeomorphic to O, and C, F, H. All these are homeomorphic to a disk. We say that they are topologically same. So what are the three important properties of topology that makes topology as a tool for data analysis? In the second row you can find the first property is topology is coordinate free. Topology doesn't depend on the coordinates. You can shift letters A, B, D, E, O, P, Q to another place, another location, but they will be topologically same. So these are doesn't depend on the coordinates. It is deformation invariant. What are the three important? You can shrink as much as you can that without any difference in the topology of the object. First property is, so shrinking is possible, compression is possible. Topology doesn't depend. Compressive representation means a continuous circle shift can be topology same as a pentagon, triangle, but so these three properties of topology depend on the coordinates. Make it as a tool to analyze data. The first one is this coordinate free. No dependence on the coordinate system topology of the object. Can compare data derivation different possible. And place at one frame, compressor can study that. A continuous circle shift, for example, you can see 10 points here, triangle, and another 10 points on the top. Properties of topology. 10 points make it as a tool. On the bottom left corner is shifted to the 10 points depends on the right top corner. Both are same. Compare data derivation different parts. Data and the structure is same. One frame, the topology is same. Study that. A continuous circle shift, for example, you can see topology properties of topology is invariant and small deformation. Another 10 points on the top. Properties of topology. 10 points. You have compressed representation of data. Bottom left corner, you can approximate or you can shift it, analyze data. The 10 points of using this two-dimensional continuous object. You can discretize that into a graph like this. The topology is same. So a circle is topology same as an hexagon. So topology is invariant and small. We can deal with hexagon without any difficulty because there are 6 nodes and approximate 6 edges. You can consider this as a graph instead of using this two-dimensional. All these circles you can suppose this same graph, bigger circle, whether it is smaller circle or bigger circle. So that doesn't make any change in the topology. Same as so we can compress a bigger one to invariant any extent you want, deal with, but not to a point without any difficulty, because there are representation of data. So what is the approximate? How do we analyze data using topology? Consider this as a graph. The topological data analysis pipeline. We have a data set, all these circles, and a metric, a distance concept in that bigger circle, whether it is data set, bigger circle. From that, we have to build a simulation complex, so we can compress a bigger one from simulation complex. Any extent we have to, but not derive the persistent diagram, persistent barcode, etc. So we will see that. How do we analyze data using? For example, what is the shape of this data? Topological data analysis pipeline. There are many points, data set, two-dimensional plane, and a metric, a distance concept. It is almost like a loop. We can fit a loop there. From that data, we have to build a simulation complex, so we can compress a bigger one. As we know, on the plane, all these isolated points and diagram have the discrete topology. So if you restrict the usual topology to this isolated point, we will have the discrete topology. So the usual topology is not enough to find the shape of this data, find the topology of this data. Almost like a loop, because when we restrict the usual topology of R2 to isolated points in R2, what we have is trivial topology, discrete topology. As we know, on the plane, so what we do is isolated points, you have take a distance d, and look at the ball of diameter d, you have the discrete topology. Center the usual topology, all the points not enough on the plane, all these points on the plane. Of this data. So we have a ball of diameter d, because when we restrict one point, usual topology of R2. Similarly, you can have balls at R2. What we have is trivial topology. Same distance, same diameter d at all other points. So what we do is, then what we do is, if these balls overlap, connect them by an edge. Connect 2 points by an edge. If balls overlap, connect these 2 points by an edge. So this is the picture that we have. So this is the simulation complex we have by connecting the 2 points. So what we do is, if the balls of diameter d overlap, what we do is, if these balls overlap, graph captures the connectivity, because there are many balls now. If many overlap, regions now. So this is the. But how do we choose the current that we have? Distance. That's the problem. Given the data, how do we know we have the current distance that we have to choose? So if the balls of diameter build a simulation complex from this. Then this graph we can dictate poles. We can dictate the homology of the data. With the homology of the data, regions now will the shape of the data. So our idea is to given the data, but how do we choose the current metric distance on the space of data? How do we know? We have to find the homology of that space. From the homology of that space, build we can find the shape of the data. Then this so we can dictate distance d. We can dictate if d is too small, so our diameter is too small. So there are many ideas to given the data, but how do we choose here? So it is like a noise on the space of data. If d is too large of that, then it connects all the points. So again it is trivial. We can find a shape. So d should not be too small. D should not be too large. So how do you find a proper d? If d is too small, find a proper d is not possible. So what we do is we vary d. There are many points from small to large, and as we vary d, you can see the different connectivities of the data. You plot those connectivity features of the data, then we can find the shape of the data. So instead of fixing a d, vary d throughout. So what we do is, as we vary d, let us see the connectivity of the data, connectivity features of the data. From the connectivity features, we can find the shape of the data. That is the process that we do in topological data analysis. Connectivity features of the data. So how do we choose distance d? The shape of the data. D is so this distance, diameter of the ball. So centered at the given points, we have different balls. Let us see the connectivity of the data, connectivity features of the data. Then from the connectivity features, you can find. Now we have process that we do, every point is in one way or the other connected. So you have, how do we choose all the points? The space is just in one component, but in the center there is a hole. So centered at the given point, you have different holes. So let us see an example here. You have 4 points on the plane. You can find. Now D1 is the distance. D1 is the diameter of the ball I have chosen. So D1, you have 4 points in one way or the other. Top left, top right, bottom left, bottom right. The space is top left one component and top right are connected because those two balls overlap. Given point, top, right. So let us bottom right are an example here because they two overlap. 4 points on the plane. Bottom right, top left are connected because those two balls overlap. D1 is the diameter of the ball I have chosen. So D1, bottom left and top right are connected because they two bottom right overlap. So we have one component and the simulation concept like this because those two balls overlap. For this diameter D1, right? If I change the diameter D1 to D2, I am increasing D1 to D2. Bottom right, D2 is greater than D1. What happens? Those two balls overlap. All and the balls overlap except bottom left and top right are connected. Top right and bottom left. There is no overlapping between. So we have bottom right, bottom left, and top. Those two balls overlap. For this,
sir, your presentation not
if I
displayed.
change the diameter D1 to D2, I am increasing D1 to D2. Bottom right, D2 is greater than D1.
Okay, sir. No, right. Thank you, sir.
All is it okay now?
Okay, sir. Thank you, sir.
Overlap except bottom left. So we have top right and bottom left. D2 greater than D1. There is no overlapping between. For D2 greater than D1, bottom right, bottom left, and
Excuse me, sir.
those two balls we have for this the
Sir,
connectivity
your
like this.
presentation not
Change
displayed.
when the diameter is D1, I am increasing D1 to D2. There is a hole at the
No,
center.
right. Thank you, sir.
But is it okay now? D1 to
Okay,
D2,
thank
the
you.
hole at the center disappeared because so we have why it is a region because 3 balls overlap. 3 balls overlap, then it will become a region.
sir.
On the top, we have 3 balls overlap. It is a region there.
Presentation not
Change.
displayed.
Left position also, the 3 balls overlap here, so it is a region. So the hole at the center disappeared when we change. Is it okay now? D1 to D2.
Thank you.
So the connectivity because so we have the diameter is D1. We have the hole in the center overlap. When the diameter is D2, there is no hole. So hole which is born at D1 died when the diameter is D2. Left position which is born at D1 died was overlap here. So it is a death, birth and death. The hole at the center. Some features born at some time. Some features die at some other time. So if you look at the birth is the death. We have, so for example, here D1 is the birth time. There is no, even though it is diameter, which is changing the diameter of time, we say that D1 is the birth time. So the time of birth of the hole is D1. So time of birth and death. Sorry, time of death of the hole is D2. So from D1 to D2, at some time we draw a bar like this. Die at some other time. Collection of holes. Birth is the death. Gives a barcode. That barcode determines the birth time. Barcode gives the topology features of given diameter. We say that D1 is the birth time. This is another example. The time of birth of the hole is D1. So time of birth and death. Sorry, time of death is visible now. So from D1 to D2,
Sir, visible, sir.
draw a bar like this. This is another example. You have the data here. You just try to record the barcode. That barcode, to record the barcode, we have to change the diameter of the board. So for each point is another example center. You have to look at the balls of diameter, given diameter. When we connect two points, if these two balls overlap.
Sir, visible,
So we
sir.
connect these two balls. This is another example or note if balls overlap. In fact, this is not a graph, it is a symmetric complex. So let us look at the barcode. I am going to each change the diameter of the ball. You have to look at the ball diameter is changing now. When we connect changing, so the connectivity is changing. if these two balls overlap.
Sir,
You can see the
visible, sir.
connectivity changes. These two balls. This is another example or notes if balls overlap. In fact, this is not. And finally, every ball is connected for some diameter, very big. Look at the barcode. Let us see once more. I'm going to change the diameter. At this point, you have to look at the balls diameter changing. At this point, there is there are changing. If these two balls see the connectivity. Two balls here. This is another and there are two components. You have the left part and the right part. In fact, for three components. There are three components. Left side very big. This is one component. Right side is one component, and there is a point here. So it is not connected at all. At this point, there are three components here and two holes. At this point, there is there are changing. Now, everything is in one component. Two holes here, and there is a big hole at the center. You have the left part and the right part. In fact, for three components. There are three components. Left side very big. This is one component. Right side is one component, and there is a point here. So it is not connected at all. Let us see. At this point, three components here and two holes. Once more. Okay. Let us see the question. Now, diagram everything is in one component. You have the barcode here at the center. The left end of the barcode gives birth time. Right end of the bar gives death time of the particular feature. A feature can be number of components, number of one-dimensional holes, number of two-dimensional holes, etc. At this point, so left and two holes. Left once more gives the birth time. Let us see. Right the question. Now. So if you plot instead of plotting the bars, you have the plot. Each bar has a coordinate at the center. The left end in which the first coordinate is birth, and second coordinate y coordinate is death. So for this bar, you have this point here. This is the number of two-dimensional left point. This is the right point. So left x-axis, y-axis. This is the birth death. The birth time, and this is the point corresponding to the small bar. So if you plot for the instead of plotting the bar, large bar here, the topmost point corresponds to the large bar. In which the first coordinate is birth, and second. So this is another visualization of the top of this bar. Instead of for this bar, looking at it as a barcode. This you can find. You can visualize as the right point. Coordinates x-axis, y-axis. This is on the plane with coordinates, and this is x coordinate point corresponding to this y coordinate gives for the death time. Large bar that representation is called persistent diagram. So we have seen two visualizations. This is another visualization barcode and persistent diagram. For this bar, instead of looking at it as a barcode, I will talk about persistence later if time permits. Coordinates x-axis, y-axis. This is on the plane with coordinates. So, how do we construct this for the edges from the given data? That which is called simulation complex persistent diagram. Zero simplex means point. We have seen one simplex visualization. This is another line. Two simplex is a triangle with its interior. Three simplex is a tetrahedron. We'll talk about persistence later if time permits. From simplexes, we can have simulation complex. So, how do we construct complex? Is a collection of simplexes. This in such a way that from the given data that at a point, which is called simulation complex, and zero simplex means point. This one is a hole, line, two simplex or one-dimensional hole, triangle. So zero-dimensional hole means number of components, tetrahedron. One-dimensional hole means actually a hole. Two-dimensional hole means simplexes space. So two-dimensional hole means a hole in which the boundary is two-dimensional. One-dimensional hole means the hole in which the boundary is one-dimensional. So we can have n-dimensional holes. N-1 dimensional holes in R is a hole, two simplex or one-dimensional hole, triangle. So this is a way to construct a simplified complex. I'm going to do that. Actually a hole. Two-dimensional hole means there are many types of simplified complexes. Two-dimensional hole means the first one or the most popular one is check complex. That's what I said now. If two balls overlap, then we join them by an edge. Then form a simplified complex. That is called check complex. Instead of this is a way to construct a simplified complex. Balls overlapping, going to do that. If the distance between the vertices is there are many types of simplified. Then also we can join the vertices. This is called vigorously. First one or the most popular one is check complex. one dimension. That's what I said now. A hole in which if two poles overlap, so then what matters, we have to find the shape of the data. That is called, how do you find shape of the data? Instead of shape of an object, poles overlapping of an object, if in some sense can be determined if you know number of zero-dimensional holes, number of one-dimensional holes, number of two-dimensional holes, number of three-dimensional holes, etc. Two poles overlap. If you know this number of what matters, we can almost find the shape of an object. How do you find shape? For example, if you ask me an object, three-dimensional object, in which there is one pole, then it can be number of zero-dimensional holes, number of one-dimensional holes. Sorry, two holes. It can be a torus. In torus, actually, we find only one hole, but there are two holes because one is number of what matters, we can almost find the shape on the two-dimensional plane shape of an object. If, for example, an object with one pole is ask me an object with one-dimensional pole. For circle, you have a one-dimensional pole. There is one pole, then it can be number of so look at the line segment. Sorry, two holes. It can be a torus. It is in one component. It is connected. It is one component. So number of components is one. If, for example, number of an object with one pole is an object with one-dimensional pole. For circle, you have a one-dimensional pole. There is one pole. Then it can be. Hello, is it visible? Can I proceed? Look at the line segment. Sorry, two holes. It can be. It is in one component. It is connected. It is one component. Stripes are visible. Can I proceed? Number of components is one. If, for example, number of an object with one pole is an object one-dimensional pole. For circle, you have a one-dimensional pole. There is one pole. Then it can be. Am I audible? Is it visible? Can I proceed? Look at the line segment. Sorry, two holes. It can be. It is in one component. It is connected. It is one component. Stripes are visible. Can I proceed? Number of components is one. If, for example, number of an object with one pole is an object one-dimensional pole. For circle, you have a one-dimensional pole. There is one. Okay, thank you. Then it can be. Am I audible? Is it visible? Can I proceed? Look at the line segment. So the beta naught, it is in one component. It is connected. It is one component. Stripes are visible. Can I proceed? Number of components is one. For example, number of components beta 1. Okay, thank you. Number of one dimensional. Is it visible? Can I proceed? Look at the line segment. Beta. So 2, the beta naught, it is one component. It is connected. Number of two-dimensional holes. Stripes are visible. Can I proceed? Etc. etc. So this beta n for beta 1 numbers. For line number of one beta naught is 1. Beta 1 is 0. The beta naught, because there are no number of two-dimensional holes. Stripes are visible. One-dimensional hole. Etc. Beta 2 is again 0. Beta n, if you take a triangle, beta 1 number. Triangle means without interior. For line number of one, beta naught is 1 because it lies 1 as in one component. Beta 1 is 0. The beta naught, because there are no, it is connected. Number of two-dimensional holes. Stripes are visible. One-dimensional hole. Beta 1 is etc. Beta 2 is 1 because there is a hole. Beta n is center. Take a triangle. Beta 1 number. Triangle means without interior. Triangle. Number of one. Beta naught is without the interior means because it lies 1 as in one component. Beta 1 is 0. The beta naught, because there are no, it is connected. Number of two-dimensional holes. Stripes are visible. One-dimensional hole. Beta 1 is beta 2 is 1 because there is a hole. Beta n is center. Take a triangle is a hole. So the triangle means without one-dimensional hole is 1. There are no two-dimensional triangle. For a triangle without the interior means because it lies 1. Triangle beta 1 is 0, the beta component. Because there are no, it is connected. Number of two-dimensional holes, types are visible, one-dimensional hole. Beta 1 is in beta 2 is 1 because there is a hole. What is beta n is center. Take a area angle here, a hole. So this is like a region, one triangular region. There are no two-dimensional triangle. For a triangle without the interior means because it's like triangle. Beta 1 is 0, the beta component. Beta 1 tetrahedron is in one two-dimensional. So the hole is two-dimensional. This beta 2 is 1. In beta 2 is 1 because there is a hole. So this beta is a hole. So this bigger region numbers triangular region. There are no two-dimensional triangle which gives number of without the n-dimensional holes. Triangle. Beta 1 is 0. The beta component. Beta 1 tetrahedron is in one for a point dimensional. So the hole is beta naught is 1. It is a 1 component because there is a hole component. So this beta 1 is 0, beta 2 is 0. So this bigger region number for a ring region. There are no two-dimensional triangle which gives for a certain number of without the n-dimensional holes. Triangle. It will beta 1 diagonal is 1 for a point dimensional. So the hole is beta naught is 1 component. 1. It is a 1 component because there is a so component. Beta naught is 1, beta 1 is 1, so beta 2 is 0. For a sphere, for a ring, sphere is connected which gives for a circle. So it is in one component. So beta naught is 1, beta 1 is there are no holes. But there is a hole in diagonal 1 for a point inside. It is a hollow sphere. So there is a hole inside the sphere. If it's two-dimensional hole, so beta 2 is 1. For the torus, beta naught is 1. S1 1 is so there is one horizontal sphere hole and there is one vertical hole. So it is in one component. So beta naught is 1. Beta 1 is there are no holes. Beta there is 2 is 1. There is space inside. Evolution 5 points in the first one. So look at the bar here for H naught. If it's two-dimensional hole, there are beta 2 is 1. For the torus, beta 10 bars. 1. 1 is so there is one for a horizontal sphere hole and there is one vertical hole. So it is second one. So beta naught is 1. Second one means beta 1 is there are no holes. Beta bottom 2 is 1. There is space inside. Evolution 5 points in the left one. So look at the bar here. First one in the bottom. If it's two-dimensional hole, there are beta 2 is 1. For the torus, beta 10 bars. 1 is so there is one for a horizontal sphere hole and there is one vertical hole. Second one, so edges are connected. Second one means more nodes are beta connected. Bottom 2 is 1. There is space inside. Nodes are connected. So number of 5 points left. So look at the bar and the first one in the bottom. Reduced. There are beta number of components. Beta 10 bars. Reduced to 1 is 4. There is 1 6 for a horizontal sphere hole and there is one vertical hole. Number of components reduced to edges are connected. Second one means more nodes are. So if you look at the bars connected bottom below that one nodes are connected. So number of 5 points can left common. So look at the bar. See first one is the bottom reduced box. There are beta number of components in no. Reduced to 1 is 4 and 6. Talking about H naught only. Number of components reduced to you can see 6 edges are connected. More nodes are bars. So if you look at the bars bottom, the third one, third one means the number of points can left common on the first one is reduced box. Top in H. It is in one component. And 6. So that gives 1 bar below. Number of components reduced to you can see 6 edges are connected. Fourth one bars. Again 1 bar. Fifth one 1 bar. For all the third one third, every one all the but nodes are connected. So it is in one component. On the now what is the H1? H1 in H1 is one component. Number of and 6 holes. So that gives 1 bar below. number of components. For the first 6 edges are connected. Fourth one, again 1 bar, fifth one bar. For all others, one edge here, every one, all the top left are connected, so it is in one component. There are no, now, one time H1, H1 in H1. So H1 is one component. Number of 1 is 0. There is no holes. So bar here, below. Number of components for the first place of H1. Fourth one, again 1 bar. For the second one bar. For all the second one edge here, that is all the top left are connected, so it is in one component. One at the bottom. Now there are two holes, H holes. So H1 is one component. Number of 1 is 0. There is no. You can see bar here below. Two green bars place of H1. Fourth one below the second one. For the second one bar. For all the second one here. For the third one is the top left are connected. So there are three. One. So this H1 gives. Now there are two one-dimensional homology. So H1 is one component. So H0 gives. There is no. You can see zero-dimensional homology. Two green bars place of H and H2 gives for the second one bar. Two dimensional. For the third one is left two dimensional homology. So this H1 gives bar diagram. There are two one dimensional homology. So H code for two dimensional homology. So H0 gives, and for the you can see zero dimensional homology. Fourth one, two green bars. One here and there is H1 for the second one here, because for the third one there is a two-dimensional homology. This two-dimensional holder bar diagram. There are two one-dimensional homology. So H code for two-dimensional homology. So another symbol like H0 gives, and for the example zero-dimensional homology. Fourth one, two green bars. One here and you have there is H1 for the C1 here, C2 because for the third one to C3, C4, C5, C6. This is an evolution of a network, like our brain, from the baby brain to another brain. It is evolution. Example, from the baby brain to when we reach the adult, you have there is brain, then C1, here C2 because more nodes are C4, C5, C connected. C6. This is an evolution of a network, like our brain, from the baby brain, more nodes, another brain. It is evolution. Deactivated from the baby brain to the when we reach the adult, as you have there is brain, then C1. More nodes are become older, connected and older. This is an evolution of a network. The connectivity becomes less. From the baby brain, more nodes, another brain. It is evolution. Deactivated from the baby brain to the so C1, as C2, C3, C4.
Sir, your voice is breaking, sir.
C5, C6.
I think your activity is
Again, and see the corresponding become older and evolution older. Bottom make it that is we know some problem with the connectivity. Let me check. From the baby brain to the so C1, as C2, C3, C4.
Sir, your voice is breaking, sir.
C5, C6.
I think your activity is
Again, and see the corresponding become older and evolution older. Bottom make it that is we know some problem with the connectivity. Let me check. From the baby brain to is it okay now? So C1, C2, C3, C4.
sir, your voice is breaking, sir.
C5, C6. Visible? Sides are visible?
Activity is
Again, and see the corresponding become older.
that's visible, sir.
Evolution older. Okay. Bottom make it that is and this is the some problem with the two-dimensional simplex V1 lambda 1 lambda 2 lambda 3. Is it okay now? This is again a convex combination of the line segments.
Sir, yeah, okay, sir. Taking, sir.
Visible? Sides are visible?
It is.
So this is a way to create
Yeah, it's visible, sir.
For every simplex we have a face. The face is given by the zero-dimensional face, one-dimensional face, two-dimensional face, and three-dimensional face. Two-dimensional simplex. V1 lambda 1 lambda 2 lambda. Another concept that we need when we analyze data using topology is
Yeah, okay, sir.
nerves. For nerve, sides are visible. A nerve means if you have a collection of sets
It's
S,
visible, sir.
nerve of S is subset of all those collection which has non-empty intersections. For example, let us look at yes, my S is ABCD, set ABCD.
Okay, sir.
Nerve of S, ABCD is given in the picture. A is nerve of ABCD is nerve of S. Nerve of S is AB, set AB, because set A non-empty set B, they for example have some intersection. So set AB is yes in nervous. S is AB. Set BC is in nervous. Set CD is in nervous. Set AD is in nervous. Given A is in nervous. A is non ABCD. Set B is there. Set C is there. Set D is there. Set ABC is not there. AB. Set ABC is not there because they don't have a common intersection. Set B. So this is my nerve, for example, have some intersection. So set AB is yes in nervous. AB. Set BC is in nervous. Set CD is in nervous. So if you take this ABCD, the nerve is AB, set A, set B, set C, set D, and all the possible combinations are there in that set. Set ABC is not there because no. As I mentioned, there are many types of complexes. So this is my check complex means if I have finite set of points in Rn, check complex for given R is given by subset of S. So if you where boundary of each ball is non-empty. So each ball is non-empty. So you get all those subsets of S, all the possible combinations are there. Boundary is rated at X and the intersection. As I mentioned, there are many types of complexes. So this is my check complex means check complex. If I have finite set of points in Rn, so you have ABCD here, for AB given by B and C are joined. Yes, so if you because where B and C there is an overlap here. A and B not joined. A and C not joined. So the all those subsets of check R1 when the radius is or the diameter, whatever radius or diameter, whatever it is. As I mentioned, is R1. Check R1 is BC. Check because there is only if I have finite set of points in R1, one overlapping is there. ABCD here. If I increase R2. The radius B and C are joined. R2 radius to R2. There is an overlap here. Check R2 and AB, BC. Because the both center A and B overlap, both center B and C overlap. That is AB, BC. Radius or diameter, whatever it is. As I mentioned, is R1. Again, if I increase the radius R3 to R3, check R3 is overlapping. AB is there, BC is there, CD is there. Because the corresponding balls overlap. R2 radius to R2, there is an overlap. Then again, if I increase R4, when the radius is R4, it is AB, BC, AC, CD. Because you can see the balls, when the balls overlap, then that makes the complex. Again, if I increase the radius, the other one is Vittori strips. To another way of R3 is overlapping. AB is there, symmetrical complex is there, CD is there. Here what we do is look at all subsets of the given set S. If the diameter of sigma is less than or equal to again if I increase edges are joined. When the radius is R4, it is AB. Here this is the check R and this is the Vittori strips R. In the Vittori strips R, the diameter is less than R, so they have joined. The region is there. In the check complex, the region is not. The other one is Vittori strips. To another way of R3 is overlapping. AB is there, symmetrical complex is there, CD is there. Here what we do is look at all subsets of the given set S. If the diameter of sigma is less than, the basic idea behind all this is homology. We have here this is the check R. and which is descending chain the diameter of CI. So they have joined. C3, C0 is one dimensional, zero dimensional chain. Zero dimensional chains are vertices. C1, zero dimensional chains are linear combination, or let us say integer combinations of vertices. C1 means integer combinations of edges. C2 integer combinations of regions, etc., etc. So and then descending chain of CI. Descending chain then of CI. This group, let us look at the group of cycles in Cn. Group of cycles in Cn is denoted by Zn. Group of boundaries in Cn is denoted by Bn. Then the nth homology group, integer combinations of vertices, is Zn modulo Bn. C1 means, let us see an example so that C2 will be clear. Integer combinations of regions, etc., etc. So let us find the homology group of descending chain. Circle is homeomorphic to triangle. This group, so let us homology group of circle is the same as homology group of triangle. How do you find homology group of triangle? You take a triangle, name the vertices as XYZ, edges as ABC. Let us see an example. What is C0? C0 is all integer combinations of x, y, and z. Let us find the homology group of integer combinations of A, B, C. That means, for example, 2A plus B belongs to C1. 3A minus C belongs to C1. How do you find homology? 4A plus 5B minus 5C belongs to C1. All integer combinations of the edges is C1. Set of all integer combinations of the vertices is C0. Let us find the homology group now. From C1 to C0 we have a boundary. For example, given an edge A plus B, there is a boundary. Belongs to C1. Given a vertex 3A minus, there is a boundary. Boundary of a vertex is 0. 4A plus 5B minus 5. This do not gives a combinations of the boundary of boundary from C0 to 0. Integer combinations. Boundary of the vertices. Boundary of x is 0. Boundary of y is 0. Boundary of z is 0. We have a boundary. Boundary of, for example, boundary 1. There is a boundary. Given a boundary of the edges. There is a boundary. Boundary of the edges are vertices. So do1 is a map from C1 to C0. This is a map from C1 to C0. What is boundary of A? Boundary of A is xy. So boundary of A, there is no orientation, but it can be written as x minus y or y minus x. But I am using the same way. Boundary of, it is y minus x. Boundary of B is z minus y. Boundary of C is z minus x. So we have boundary of all the edges. Now what is z naught? This is z naught. What is kernel of boundary of A is do naught. Kernel of do naught. So there is no orientation. All those elements can be in x minus y or y minus x. But I am using do naught is from C0 to 0. So let's look at all those y minus x. Boundary of maps to 0. Z minus y. All those elements in C0 z minus x maps to 0. All the elements in C0 maps to 0. X goes to 0, y goes to 0, z goes to 0. So is it not the same as C0? What is B naught? B naught is image of do1. Image of do1. Those elements. do1 is a map from V1 to C0. Look at all the images in C0. All the images is y minus x. It is y minus x to 0. Is z minus y and z minus x. So we have all the elements in C0 map is it not modulo B naught? Is it not modulo B naught is it not the same as C0? Combinations of x, y, z, b naught and modulo combinations of y minus x, z minus y, z minus x. How do you find the modulo? Yeah, then this modulo, this quotient is nothing but x itself. All the images means y minus x. Multiples of x. Multiples of x means it is same as integers, set of integers. So we have h naught of is the circle is group of integers. Modulo b naught is it not the same as combinations of x, y, z. Similarly, you can find h1, h2, etc. Z minus y, z minus x. So this is h naught of. Yeah, then this modulo, this quotient is a disk is homeomorphic to a triangle with interior. Multiples of x. Multiple triangle with interior. It is same as you can find h naught. So h naught of. I'm not going to explain all this. Group of integers. Modulo b naught is it not the same as And the idea of persistence emerges from one-dimensional persistence. What is one-dimensional persistence? We take a graph, then this function brought the graph of the function is y equals to a triangle is interior. There can be many minimum and maximum points interior. And if H0, take the minimum point, then the level set of the minimum point need not be connected. The idea of persistence that is emerged from f inverse of say T2. F inverse of T2 graph is not connected. F inverse of T2 lies in two components. There can be many and minimum and maximum points. Three components. This interval, this point, and this interval. Take the minimum point. F inverse of T3 is in two components. F inverse of T4, three components. F inverse of T5, two components. F inverse of T6, one component. So, number of components changes. F inverse of T2 lies in two components. The Ti varies. Three components. T1, this is interval, one component. F inverse of T1 lies in one minimum point. F inverse of T2, two components. F inverse of T3, two components. F inverse of T4, three components. F inverse of T5, two components. Two components. At maximum points, number of components reduces. Number of minimum changes. Number of components increases. That is a persistence. So, number of components varies. Emerges at minimum point. Number of components dies at maximum point. Lies in one component. The idea of persistence of T2 is emerged from this concept in one-dimensional persistence. F inverse of T4, three components. F inverse of T5, two components. Four components. In these examples, number of components reduces. Number of minimum changes. Let us see some applications. That is a persistence. How do we plot point? Number of components we have an image of a cycle. At minimum point, you have a cycle here, image of a cycle at maximum point. And it is plotted in MATLAB here. This is the cycle. The points on the cycle, this image is plotted here, and this is the point cloud of the cycle. Minimum is the point cloud of the cycle. See some application. Corresponding persistence diagram is given. How do we plot point? Number of components we have an image of a cycle. At minimum point, you have a cycle here, image of cycle. There are many applications, and it is plotted of this data analysis in MATLAB here. This on a cycle. If you look at the points for cycle, patient with Alzheimer's is their structure, and this is the point of the hippocampus differs. Is the point cloud of the cycle. Some application. Structure of the MRI image is different. And this is a moderate Alzheimer's patient. Again, you have point cloud and corresponding persistence diagram, and this persistence diagram is different from the other two. Again, you have point cloud and corresponding persistence diagram. This is a mild Alzheimer's patient, different from the other two. Again, you have this persistence diagram is different from the. This is a mild Alzheimer's diagram from the other two. Again, you have this persistence diagram is different from the. This is a mild. From the persistence diagram, we get information. So, from the persistence diagram, this can be used to predict whether someone gets someone will have Alzheimer's or not. So that you have to train one algorithm, will have Alzheimer's algorithm using topological techniques. So that you have to train, say from 60 years to say 80-year-old. You can train the algorithm. Say after training to say, then you can use the algorithm to predict whether algorithm someone will have Alzheimer's or not. That's the work that we are doing now. Will have Alzheimer's or not. And that's the work that we are doing now. This technique can be used to optimize flight trajectory. And that's the work that if you take a particular flight, can be used to optimize flight trajectory. And that's the work that is different in different days. Flight trajectory is not unique. Flight goes is different in different days. In different paths, same flight goes different paths. Is different in different days. In maybe because of turbulence, same flight goes other weather conditions, etc. In different days. But maybe because of turbulence, same flight goes other. How do you find the different days best? But maybe because of flight trajectory, optimized trajectory. How do you find the optimized flight trajectory? Depends on many things. Flight trajectory, optimized. How do you find the time-based flight trajectory? Depends on many things and many other things. So how do you find the time-based flight trajectory? Depends considering and many other factors. So we can optimize flight trajectory using topology techniques and many other factors. So we can optimize. Here we have the flight trajectory. You can see holes in between. The holes here we have indicate the flight has not traveled through that region. That's why here we have indicate the flight has not traveled, didn't travel through that region means there are indicate the flight many reasons for that. Didn't travel. First of all, we have to find the reason. There are can be turbulence. From the turbulence plot, we can identify whether there is turbulence or not. Find the reason. There can be many some other aircraft in that region. So there can be many may not go through that region. Aircraft, that is another possibility. So there can be many may not go through that region. But if you that is another possibility. One flight for say for 1 year. If you that is the one flight for trajectory say for 1 year, a topological sphere with many loops say for 1 year. From that we can identify sphere the optimized trajectory. Many loops say for 1 year. From that, so that is another research that we are doing now. And to plot show this research that we are to plot point cloud, position bar, diagram, barcode, etc. There are many softwares available. JavaPlux is one software. Diagram, barcode, etc. There are many softwares available. JavaPlux is one software. Diagram, it can be installed in MATLAB. C++ code, PAT is another installed in MATLAB. Geometric understanding higher dimension Buddhi is another one. Pixar is another software. It is a popular software to plot position diagrams and barcodes. It is a popular software to plot position diagrams and barcodes. It is a popular software to plot position diagrams and barcodes. It is freely available. It is a popular software to plot position diagrams and barcodes. It is freely available. So I'm not going to do all this. So these are some references. Freely available. I'm not going to. First one is the. So these are some references. Important paper or the. I'm not going to. First one is the. So from which some references. This important paper or the. On the local behavior of natural images, from which some references this idea paper or the and topology and data is images from which a readable paper for the basic and topology and data is the methods from which a readable paper for the basic and topology and data is the methods. Thank you. Readable paper for the basic and topology and data is the methods. So any questions you can ask. And topology and data is the methods. So any questions you can ask. So any questions you can ask.
Participants, if any queries you have, you can ask. Question answer session. Participants, if any queries you have, you can ask. Question answer session. Participants, if any queries you have, you can ask. Question answer session. Participants, if any queries you have, you can ask. Question answer session. Participants, if any queries you have, you can ask. Question answer session. Participants, if any queries you have, you can ask. Participants, you can ask your queries. 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 Participants, you can ask your.
Thank you, sir. Respected our chief guests and esteemed faculty members, we are grateful for the enlightening mathematics sessions we had today. Your presence and participation were grateful for the enlightening mathematics sessions. A special word of appreciation to our chief guest, Dr. P.B. Vinod Kumar, for taking the time to share valuable insight with us. Your expertise and passion for all mathematics inspire us all. We all extend our thanks to organizers and volunteers who work tirelessly for us. Thank you once again, and we look forward for more engaging sessions. Thank you.
Thank you. I'm really sorry for the connectivity issues. Disturbance caused by connectivity issues. Thank you. I'm really sorry for the
We have
connectivity
shared this
issues.
in
Disturbance
YouTube
caused by
channel also.
connectivity
Live
issues.
session is
Thank you.
going
I'm
on.
really sorry for the
See,
connectivity.
we have shared this in YouTube channel also. Live session is
Thank you.
going
I'm
on.
really sorry for
Thank
the
you.
connectivity.
We have
Thank you.
shared this
Thank
in
you.
YouTube channel also. Live session is
Thank you.
going
I'm
on.
really sorry for
Thank
the
you.
connectivity.
We have
Thank you.
shared this
Thank
in
you.
YouTube channel also. Live session is going on.
Okay.
Thank
Thank
you.
you.
We have
Thank
shared
you.
this
Thank
in
you.
YouTube channel also. Live session is going on.
Okay.
Thank
Thank
you.
you.
We have
Thank you.
shared this
Thank
in
you.
YouTube channel also. Live session is going on.
Okay.
Thank
Thank
you.
you. Thank you. Thank you.
Patil sir, can we start next session, sir? Patil sir, can we start next session, sir?
I mean, no problem.
Patil
Then you
sir,
can.
can we start next session, sir?
I
Yes,
mean,
sir. Thank you, sir.
no problem.
Patil
Then you
sir,
can.
can we start next session, sir?
I
Yes,
mean,
sir. Thank you, sir.
no problem.
Patil
Then you
sir,
can.
can we start next session, sir?
I
Yes,
mean,
sir. Thank you, sir.
no problem.
Patil
Then you
sir,
can.
can we start next session, sir?
I
Yes,
mean,
sir. Thank you, sir.
no problem.
Patil
Then you
sir,
can.
can we start next session, sir? Yes, sir. Thank you, sir.
No problem.
Good morning, everyone. Ladies and gentlemen, please join me in welcoming Professor P.G. Patel, a renowned mathematician and educator from Karnataka University, Dharwad. With 22 years of teaching experience and 20 years of research experience, Professor Patel has made significant contributions to mathematics, particularly in Fuzzy topology and soft set theory. He has published 74 research articles, guided several research scholars, and delivered numerous special lectures. We are honored to have Professor Patel with us today. We welcome you, sir. We are honored to have Professor Patel.
Hello.
Yeah, thank you, sir. You can start your session, sir. It's yours. Thank
Hello.
you. Yeah,
If
thank you,
there's
sir.
no
You
problem, I
can
can start. No
start your
problem.
session, sir. Yeah, you can start, sir. Thank
Hello.
you. Yeah,
Okay,
thank you,
ma'am.
sir.
Okay,
You
just a
can
minute. No
start your
problem.
session, sir. Yeah, you can start, sir. Thank you.
Hello.
Yeah,
Okay,
thank you,
ma'am.
sir.
Okay,
You
just a
can
minute. No
start your
problem.
session, sir. Yeah, you can start, sir. Thank you.
Hello.
Yeah,
Okay,
thank you,
ma'am.
sir. You
Okay, just a
can
minute. No
start your
problem.
session, sir. Yeah, you can start, sir. Thank you.
Hello.
Yeah,
Okay,
thank you,
ma'am.
sir. You
Okay, just a
can
minute. No
start your
problem.
session, sir. Yeah, you can start, sir. Thank you.
Hello.
Yeah,
Okay,
thank you,
ma'am.
sir.
Okay,
You
just a
can
minute. No
start your
problem.
session, sir. Yeah, you can start, sir. Thank you. Yeah, thank
Okay,
you,
ma'am.
sir.
Okay,
You
just a minute.
can
No
start your
problem.
session, sir. Yeah, you can start, sir. Thank you. Yeah, thank
Okay,
you, sir.
okay,
You
just a
can
minute.
start
No
your
problem.
session, sir. Yeah, you can start, sir. Thank you. Yeah, thank
Okay,
you, sir. You
okay, just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir. You
Okay, just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir. You
Okay, just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir. You
Okay, just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir. You
Okay, just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir. You
Okay, just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir.
Okay,
You
just a minute.
can start your session, sir. Yeah, you can start, sir. Thank you. Yeah, thank you, sir. You can start your session, sir. Yeah, you can start, sir. Thank you.
Okay. Okay. Madam, hello. Okay. Hello,
Yeah, yes, sir.
madam. Hello. Is it audible?
Yeah, audible,
Hello.
sir. Your screen
Madam.
also visible, sir.
Hello. Is it audible? Okay,
Yeah,
ma'am.
audible,
Hello.
sir. Your screen
Madam.
also visible, sir.
Hello. Is it Can I start, ma'am? Okay,
Yeah,
ma'am.
audible,
Hello.
sir. Your screen
Madam.
also visible, sir.
Hello.
Yeah, yes, sir. You can
Can I
start,
start,
sir.
ma'am? Okay.
Yeah, audible,
Hello.
sir. Your screen
Madam.
also visible, sir.
Hello.
Yeah, yes, sir. You can
Can I
start,
start,
sir.
ma'am? Okay.
Yeah,
Good
audible,
afternoon
sir.
to all
Your
of you.
screen also visible, sir.
The
Yeah, yes,
respected
sir. You can
Can I
start,
start,
sir.
ma'am? The
Yeah,
organizing
audible,
committee
sir.
to all
Your
of you and
screen also
management of
visible, sir.
the
Yeah,
respected
yes, sir. You
college
can start, sir.
and my dear participants.
All of you
And management of the
yeah,
respected First, I would like to thank the
and
organizers for giving me an opportunity to share my few ideas in this junction. few ideas. And this topic, that is new approach to MCD problems using fuzzy binary soft. This topic, it is a simple topic that those who are in the starting for the research as well as just for MSc final year students, it is very helpful for them. I hope that. Now, the new approach to MCD problem using fuzzy binary subsets. The abstract of this talk is the many real-world problems faces strenuous in making decisions. Many theories have evolved for dealing with such problems. The real-world problems can be solved by fuzzy set theory and soft set theory. In some cases, these theories may not efficiently deal with real-time applications. In such situations, fuzzy binary subsets are efficient in solving of MCDM problems. The expanded matrix representation of fuzzy binary subsets, an extended resultant matrix, and operator are listed which overcomes the limitations of fuzzy subsets. This is the abstract of my talk. Before going for the presentation of this one, I want to explain what is the necessity of fuzzy set theory, soft set theory. Then you are going for the binary subsets as well as fuzzy binary subsets. While introduction of this one, the question arises: difference between human intelligence and machine intelligence. The question arises because human intelligence has ability to think and take decisions under uncertainty. Therefore, human intelligence can perform tasks such as recognition of speech, translation of languages, comprehension of meaning, abstraction, generalization of summarization of informations, and in some cases that is we can easily task them. You can easily solve them. But whereas the machine cannot do all this work, we cannot find the solutions from the machines here. Means we can say that it has not been possible to design and construct a machine which can compete with humans in performing the task of the mentioned these that is what we taking an examples. And so and also in some problems means in ambiguity we can say that terms like tall, warm or fast or inherently warm or fast. In such situation, we cannot go for the that is binary set theory. In the binary set theory, only we can say that yes or no, or true or false. Means or not. Only we can say that they are. Only we can say that yes or no, true or false, or you can represent by zero and they are here. Only we can say that yes or no. Put in what about this in ambiguity situations? Just like the tall students in the class. Tall students in the class. Tomorrow may rain come. As well as today it is an warm day. In such situation, the crisp set theory fails to give the solutions because these are all ambiguity in nature. Then how can this one can perform this such type of task here? And because of the human brain, human can think. The difference between the human intelligence and machine is mainly due to the ability of human brain to think and reason in precise, non-quantitative, non-quantitative and vague terms. But the machine cannot do all these things. Then the question arises: how to make the machines think? That is, how to design and construct the machines having ability to think. This question addressed by addressed in the 1965 by Professor Latif A. Jade in the year 1965 by introducing to solve such type of problems by using this fuzzy set theory here, that he introduced fuzzy subset and fuzzy logic. But the question arises, there is a all type of there is a human intelligence difference, it is mainly due to the human brain. But how to reduce the gap between machines and human intelligence, machine intelligence and human intelligence? There is a huge gap is there. We cannot say this one. Therefore, they are in opposite. But we can say that is there gap is there. We can reduce it by using this fuzzy set or using any new techniques here. That Professor Elage had said that using the fuzzy subset and fuzzy logic, we can reduce the gap between the human intelligence and machine intelligence here. But whereas in the crisp set theory, only two options are there. We can say that that is also a Boolean logic also. We can say that it is a membership or an non-membership. Suppose if an element in the given set is there or not, we can only say that whether it is belongingness or not belongingness. But in the crisp set theory, but that is not case in the fuzzy set theory. We can say that membership of that element, it is ranging between the nil membership 0 and the full membership 1. It is between 0 to 1, that is in the closure interval 0 1. And he introduced that. And after introduction of this concept, the floodgates are open of research work in the areas of mathematics and computer science. The research gap, that is research areas, they are just like an floodgates. The many cases they are into the research is in the field of computer science and mathematics, including areas such as in the artificial intelligence, image processing, neural networks, and many more in the computer science as well as in the mathematics. But despite of all these advantages, fuzzy sets fail to efficiently handle real world problems having the parameters. Nowadays, parameterization is very important because we need a solution with respect to the requirement of an person who want to deal with the situations. Because I need this one in particular form. Means, for example, if a candidate wants to choose a college with respect to the course in good colleges, means the that is not the case in the fuzzy set theory here. Because of their huge applications also, it fails in the parameterization. Hence, the parameterization of sets becomes necessity. Consequently, in the 2010, Professor Maldostro introduced a parameterization set that is called the soft set theory. And it can be defined as a mapping from the parameter set to the power set of an universal set. And soft sets have a simple mathematical structure that makes them easy to understand and apply. Instead of assigning the membership degrees, soft sets associate elements with the parameters, making them more adaptable to real world problems. But while fuzzy sets have initial memberships in membership function, they struggle with the parameterization and decision making. But soft sets are parameterized decision making but lack the ability to deal with the degrees of uncertainty like the fuzzy sets again. In real world applications, for example, in the medical diagnostics or in the stock market analysis and in the risk assessment, decision making involves both uncertainty and multiple influencing factors, that is the parameters. The combination of these two models led to the fuzzy soft set theory, which overcomes the limitations by incorporating the both membership degrees from the fuzzy sets and parameterized representation from the soft sets here. Whereas in the fuzzy set theory, there is a lack in the parameterized soft sets here. Fuzzy sets, that soft sets, there is a parameterization. But the the membership degree, the parameterized representation for mediation. In that both that means involves both uncertainty and multiple influencing factors. That is in this situation, we need the both membership degrees as well as parameterized representation. That can be done by using the fuzzy subsets here. And in the fuzzy subsets also, it is also some cases it is also difficult to handle two involved in this set only an one universal set, in the fuzzy set also an universal set. You need two universal sets necessary. For example, if you take the for the combination of college and courses, subject and teacher, player and a coach, cars and engine, etc. While dealing such problems, fuzzy sets, soft sets, fuzzy soft sets are not enough because they contain only one universal set. Whether it is visible, audible, hello, hello,
Yeah, visible, sir.
audible,
Yeah, audible also, sir. Yeah, visible, sir.
audible.
Yeah,
In
audible
such
also, sir.
situation, dealing with such
Yeah, visible, sir.
problems, fuzzy sets,
Yeah,
soft
audible
sets,
also, sir.
fuzzy soft sets are
Yeah,
not
visible,
enough
sir.
here. There is a need set
Yeah,
that
audible
deals
also,
with
sir.
such type of
Yeah,
problems.
visible, sir.
Therefore, they introduce that is
Yeah, audible also,
binary
sir.
sets here, binary subsets. Binary subsets deals with the two universal sets and a parameter sets here. And it can be defined as a mapping from, that is a here. And it can be defined as a mapping from, that is a here. And it can be defined as a mapping from, that is a here. Script set, subsets. Yes, binary subset can also be defined as the extension of subsets as the parameterization tool involving two universal sets, while the subsets are the parameterization tool involving single universal set. Again, and also here, single in the binary subset, they are not involving the degree of membership here. But we need the degree of membership again to a degree of membership. It is in the because it is necessary in the real world problems to handle the uncertainties. We need a degree of membership. That degree of membership is in the fuzzy set only, but not in the soft set or in binary soft set. Therefore, combining these two sets, that is we have introduced that is in the year. Sorry, in the year we have introduced that is in the year. Sorry, in the year for the short set theory in the year 11. Metadata give the remarks on fuzzy binary subset and characterizations here. Using this one, remarks on fuzzy binary subset and characterizations here. Using this one, the binary set combined the fuzzy sets with binary subsets as a binary subsets where in such cases parameterization binary subsets where parameterization as well as the membership degree involving the two universal sets here. Hence it can be defined the fuzzy binary subsets from the parameter set to the Cartesian product of two power sets of fuzzy subsets of two universal sets or more effective tool to dealing with such problems with problems having the uncertainty and multiple influences here. And what is the MCDM problem? Multi-cluster decision making problems here. And very complicated. The accuracy of the knowledge is more crucial in obtaining the solutions of a machine MCDM problem. And there is an uncertainty in the data or information available to make a decision. Fuzzy numbers are has a significant influence on the decision making process. That is the next is that is in the fuzzy numbers here. But we are to discuss only on the fuzzy binary subsets here. Before that, we are going for some basic definition. Already we are familiar with the definition of fuzzy set. It is a function from the universal set to the definition of 01, that is called our membership function. And in the fuzzy soft, that is a soft set theory. Suppose X be an universal set and E be the our parameter set. If you take a subset of E, that is a parameter set, subset of a parameter set, then define a function from f function f from A, that is the subset of a parameter set to the power set of x. Then this one is called an f soft set over the universal set x, and it is denoted with f comma A here. Similarly, we can go for the fuzzy soft set. Similarly, it combining the our degree of membership and parameterization. It combining the set of parameters, and here f is a function from parameter set to the set of all fuzzy subsets of x. Means there is a combination combining the our membership degree as well as the parameterization, that is function from the parameter set to the power set the all fuzzy subsets of x, and it is also denoted by f of a, that is called our fuzzy subset of x. Now, then we are, as you think, there is a problem for the such problems, that a combination of two universal sets, the college and courses, binary sets, that is if u1 and u2 be your two universal set and E be the power parameter set, then there is a function if u1 and u2 f be your two universal set and E be the power Cartesian product of power set of u1 and power set of u2, then the set is called as binary soft set over the two universal set u1 u2. Binary soft set over power set of we need one. Again, it is the binary soft set. There is no membership declared. We need one. But we need in the uncertainty problem, binary soft situation, in our some MCDM problems, we need a degree of membership as well as a parameterization. Therefore, gas is defined. The another one, the definition it is that called the fuzzy binary soft. Another one, the definition it is fuzzy binary soft means again fuzzy binary set, and A B is a subset of a parameter set. Then there is a function from and A B f from the parameter set to the Cartesian product of the and f fuzzy, the set of all fuzzy subsets of u1 and u2 respectively. That is f from A to p of u1 cross p of u1 and where p of u1 and p2 are the set of all fuzzy subsets of p of u1 and u2 respectively. Then we say that it is the fuzzy binary u1 and over u1 and u2. Then in some situation either the fuzzy sets, fuzzy soft set, binary soft set. In such cases, there is an MCDM problem. We can write the problems in the systematic manner. Means we can write it in the systematic manner. It is easy to solve the problems, or it is easy to understand. In that case, we can express them into the systematic form, that is called the matrix form. Express them into the in that one there is one resultant matrix. It is nothing but it is a square matrix in which objects are names of the universal set labeled as a rows and columns, and entries are denoted by Cij as a row alpha ik minus alpha jk, where alpha ik is the membership value of the ith object and kth parameter. This is the resultant matrix of object and now to take an example, that u1 equal to there are three. Now we are considering badminton players u1 u2 u3 from a certain city x, and the another universal set v1 v2 v3 is a set of badminton players from the other city one. Now to take the parameter set, because depends upon the problem, the badminton players either we need their strength, fitness, power as well as the defense also. We may put the other parameter also, their strength, fitness, means the stroke maker, and also the environment. These are some parameters also there, but here we have to take only the four parameters that is called strength, fitness, power, and defense. They are denoted by the parameters as U1, E2, E3, E4 with a setup and for that we can take a set A equal to, that is it contains only the parameters E1, E2, E3. We need strength, fitness, and power only. We need this much. Therefore, for this one, we have to find the fuzzy binary subset. Therefore, to define the function from A to the P of U1, that is the Cartesian product, that is P of U1 cross P of U2 here. Define the function A, that is associated with an element U1. These numbers, the range 0.9 by U1, 0.4 by U2, 0.7 by U3 means that the grade of members with respect to that parameter is 0.9 for the U1. Similarly, 0.4 for U2, for 0.7 for U3. That with respect to the U1 means the strength of that player. Similarly, for the another set, that is P, another badminton players are there in the another universal set for the city one. That is 0.2, 0.2, 0.8 respectively. Similarly, for the what are the membership grade with respect to the parameter fitness, that is also we can take these data that we are taking by random, not by any sources of that one here. We may take the sources from the set of data is available, we can fit and solve the problem. But I am taking here only the random values here. Similarly, for the parameters that here, parameter E3, the fudge is that is defined as it is 0.6 by U1, 0.5, 0.7 for E3, 0.3, 0.8, 0.9 for the P1, P2, P3 prayer. Then this set F is called the fuzzy binary subset. Then once you have to write on this one, here there are the parameters are simple, only three parameters you are taking. If there are four parameters or five parameters here, or the members in the universal set and the members of the second universal set, if there are 5, 6, 7 and more is there, then it becomes, then expansion becomes lengthy. Therefore, how to convert, write on this one is the systematic part. That is called to put all these data in the matrix representation. That is fuzzy binary subset can be represented by the matrix. That is denoted by MFP. Means is systematically in the form of a matrix. Represent fuzzy binary subset. Rows of the matrix are labeled with the parameters. Here are the parameters U1, U2, U3. There are three parameters and three labeled with the parameters. But six players are there. The columns are labeled as the elements of an universal set. Elements of universal set are players. That is U1, U2 with respect to 0.9 parameters. That U2, U3 and U1, U2 with respect. Once this expression in the matrix is representation, then the question arises again with respect to the parameter set. Is it possible to separate the universal set U1 with respect to the parameter, universal set with universal set U2, another with respect to the parameter? That universal is called as expanded matrix representation of fuzzy binary subset. That means once we represent it, the fuzzy binary set in the form of matrix, now split that one matrix into two matrices according to the two universal sets. That is called as expanded matrix representation, that F1 is. Therefore, U1, U2, U3. This is on U1. That is universal set U1 with respect to the parameter. This matrix on and U1 is another matrix for universal set U2 separately. Very simple. Separating that one. From this one, you can easily separate the two matrix. Split the matrix into two matrices according to our universal set. We can say M1FP is the matrix corresponding to the first universal set, and MTFP is the matrix corresponding to the second universal set. The first FP and MTFP is the represent the fuzzy binary subset. First you have to represent in the matrix form. Then you can go for fuzzy expanded matrix. After the matrix representation, we can define the AND operator. If F is a fuzzy binary subset for the U1, U2, and F1A and F2 are the two FP matrices. Then the AND operator between M1A and M2A. Then the AND operator it is deferred x, it is fxy is the minimum of deferred x with respect to the corresponding element. That is the AND operator. From this, applying the AND operator to the above first example, we can take here. Find above first example with respect to the U1, that is parameter U1, U2. The minimum of this one is 0.2. Similarly, U1, V2. The minimum of U1 is V2. Similarly, U1 is also, sorry, this is V1, V2, V3 also it is. The point 2, again it is point 2, and next one is U2 V1, U2 V1, this one, and that is U2 V1, that will come as it is a point. Similarly, you can find out all these with respect to the parameters and by applying the AND operator. Operating the AND operator, then we can write down the exponential resultant matrix in the row and operator. Then we can write down the exponential matrix. Combination, these are all necessary in our MCDL problem is what? These are all necessary is involving that. Along our MCDL problem is step one, write a given data in a 20 binary subset and represent it in a matrix form. Step one, write a given data. Once the problem is given, we can convert it into the 20 binary subset and represent it in the matrix form that is in the first one. Once we convert it into the matrix form, then convert given 20 binary subset into an expanded matrix form. That expanded matrix form. 2 inverse set is a 3 expanded matrix. 3 inverse set is a 3 that we can go for. But here we are considering only the 2. That's why we are using the matrix representation. But here we are considering the step 3 is what obtaining the expanded matrix, then we go apply the AND operator that we defined in previously. So matrix operator step 2. Once we apply the matrix to the AND operator to the expanded matrix form, then with help of that we can find the expanded, that is the resultant matrix. Then that already defined that. With help of that definition we can resultant matrix. Once the resultant matrix is there, we can find the row sum of all the rows of the expanded resultant matrix. Once you find the row sum, then identify which one is the highest sum. That will be the sum. Then identify. For this one, we need. Let us take an example. For this one, take an example. Suppose we want to put the best course in X college. Because for that we are suppose the parents as well as parents are discussing for their what is join the good college, parents are the good course. Therefore, in that course they need their certain parameters are there. If you want to join the college, they need in that course they need their certain whether they infrastructure requirement, city facilities, lighting facilities, and they also think about all that. That criteria is a parameter. Suppose to the best score in city X college, there are choice of 4 colleges and the best score. Here, choice is and a subject, means just like a course. Here, E1 is a 4 colleges, E1, E2 courses, set of choice of colleges, E1 is city X, and these are the courses to be selected by the suppose the candidate wants, and these are the candidate, I need the course in the particular class. In our city, there are 4 colleges are there. Which college I can choose? In our city, and my favorite subjects are courses are V1, V2, V3, V4. For example, mathematics, or electronics communication, or computer science, or mechanical engineering. In that case, we choose which one is the best. The question comes. We want these are the parameters. Good college, infrastructure, good course, facilities, and these are the courses V1, V2, V3, V4. V1, V2, V3, V4, and they are the courses. Maybe electronics, maybe electrical, or computer science, or civil, or mathematics, or physics. The courses here. These are some parameters. In the colleges, the courses are there. What are his requirements here? His requirements are parameters. The colleges are there. What are his requirements? College is good. These requirements are secondly infrastructure. Third one lab facility. The fourth one is the library and similarly other aspects. Third one lab facility. All these other data but through the back support in a Google format. All the data has to one by in this one, this is fuzzy set. With respect to the parameter E1, for the E1 call is point 2, E2 is point 2, with respect to the parameter E1, E4 is point 1, similarly for forces, D1, V2, V3, V4 degree of that is degree. Similarly for the set of parameter E2, parameter E3 and the parameter E4, this is the fuzzy set. Once we have introduced the fuzzy set, that we express our problem in the form of fuzzy set with respect to parameters by the fuzzy binary subset. This is the first one. The fuzzy binary subset represents to the binary subset. Because once you have the represented in the right down in the fuzzy binary subset, then represent in the given fuzzy subset in the matrix. Means these are the elements of course that is universal set Q1 and Q2. Elements Q1, Q2, Q3, Q4 they are called as Q1, V2, V3 are the Q4 courses and these are the parameters. Yeah, they are called in the last slide. The rows are represented by the and these are the parameters and columns are represented by the elements of our universal set. From this one you can find the point to point with respect to the parameter. These are the this is the first step in representing the given data as a fuzzy binary sort data. This are sets in a matrix form. Once you represent the given data in the matrix form, the second step is the writing the expanded matrix form. In the expanded matrix form is what 5 to 2, 0.4, 0.1, 0.1. Means one universal parameter split into the our this matrix is split into the two sets according to the two universal sets. U1, U2, U3, U4, similar for P1, V2, C3, U4. Once you obtain the extended matrix from the given problem by the step 1, then step 4, you have to apply the AND operator. And that obtained here, that obtained in the here, this is the applying operator. Whether this slide is visible? This is the applying operator. Whether this slide is visible? This is the applying operator. Whether this slide is visible? This is the applying operator. My slide is visible or not?
You are visible, sir.
My slide is visible or not? Sure. And by
You
using
are visible, sir.
the AND operator, we apply the AND operator for the and both the expanded
You are
matrix
visible,
form.
sir.
And operator that is U1 V1 with respect to parameter U1 you have minimum value is what here we are applying U1 V1 with respect to parameter U1 similarly apply the U1 V2 by the AND operator minimum is 5 similarly apply U1 V2 it is with respect to the parameter U1 we apply U1 the AND operator to the two expanded matrix we will get this matrix after applying the AND product we get a matrix here. That is the step 3. Once you have to apply step 3, then we apply the resultant matrix definition. Alpha is a minus alpha k minus alpha j. Now first one is the U1 V1. You have to apply this one. This 0.2 minus 0.2 0, 0.1 minus 0.1 0, 0.4 minus 0.4 0, 0.4 minus 0.4 0. This 0.1 minus 0.1 0. Then 0.2 U1 V2 minus 0.2. You have to apply these two. Then we'll get it as a 0.4. Similarly, that U1 V1 that U1 V2 minus U1 V1 U1 V2 you have to apply that for all these AND operators for U1 V1 to U4 U4 will get a first one here. That similarly U1 V2 U1 V3 U1 V4 and similarly universal set with respect to the course you will get after applying the resultant matrix definition you will get this resultant matrix called as a extended resultant matrix here. And observe that this matrix it is a skew symmetric matrix. See that And observe that this the principal diagonal elements they are zeros. We get a skew symmetric matrix. Once you obtain the skew symmetric matrix, we get a then the last step is what they are saying. Once you find the row sum of this extended resultant matrix. Then the sum of this row, sum of the second row, sum of the third row, sum of the fifth and so all the one. You can apply this one here. Resultant matrix. 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 You can apply this one here. After finding the and matrix, finding the row sum stepwise arrive with the row sum and matrix ith row. Whether this slide is visible, some stepwise arrive with the row sum and matrix ith row. Whether this slide is visible, some stepwise arrive with the row sum and matrix ith row. Whether this slide is visible or not. Hello. Whether this slide is visible
Yes,
or
sir,
not.
it's visible.
Visible. Hello.
Yes,
Yes.
sir, it's
You can find
visible.
the array with the row sum. First row sum is the sum of all that
Yes,
elements
sir,
is
it's
minus
visible.
1.8. That is U1, V1. Similarly, R2 row, R3
Yes,
row,
sir,
and so
it's
on.
visible.
Totally there are 16 rows come. In that 16 row, 0.4 is there. Now,
Yes, sir, it's
which one is the
visible.
highest here? That is the 12th row. That is 23 point. Which one is the highest here? Now, similarly, 23.8 is ranking with respect to what? U3 college and Q4 course. 23.8 that question. Ranking with respect to what? How to find? In some cases, the values are same. Here it is 23.8 is the highest comes out. But in some situation, there may be equal also. It is minus 1.8, minus 1.8. How to analyze all these that can be, first you have to plot the curve, that is called a parameter curve. That can be asserting the value of ui for I equal 1 to the parameter of applying the AND product corresponding to each parameter. This is the one parameter curve. The second one is the, by using the resultant matrix, we can plot the graph here. By plotting the values of ui correspond to their row sum obtained after the step 5. Second one can correspond to their row sum. Now the discussion about how to come to the conclusion. The question. Now our presentation, that is our aim is what to relate one universal set to the another universal set of a fuzzy binary software. Relate one universal set to means for college to the course. Relate one universal set. In such cases, in kind of problem, we must decide which course is best in the four colleges. That is U1, U2, U3, and E4 college. And which college is better for can vice versa also, which college is better for the course, which college is better for B3, B4 can vice versa also, which college is for this we have to discuss about the fuzzy binary soft matrix and matrix representing the binary soft matrix. What we discussed there, we need all these means 1 to 5 steps are necessary for this cases. We need all these. That means the first step in that algorithm reduces the given data into the into a fuzzy binary soft matrix, returns in a matrix form. The second set helps to expand that matrix. Step 3, apply for a AND operator. The second and resultant matrix we can obtain. After resultant matrix obtained, then we can apply the resultant matrix. After applying this one in step 5, we get the row sum matrix here, which gives out the summing format. Now, considering row sum, which gives out, we can rank the colleges first. Now, rank the colleges or U1 or U2 or U3 or U4 for the courses P1, P2, P3 for P4. First you have to college with respect to the course. Similarly, you can rank the course. Means you have to college. I need this course, computer science course. It is in which college it is good. Similarly, this is I need a good college, but in college, which course is better? That can be both the sides we can find. Which course this can be automatic fixing you want. First we go for college, which is the first order. This can be you want where the college is and varying one courses. Similarly, in the same way, if you want to choose the course, and first you have to fix the course, then choose the college. In which college the course is best? And first you have to fix that is fixing the icon and varying the college. Now clearly we can see that for fixing first one, you have to see that in the clearly we can see that for fixing first one, you have to see that in the clearly we can see that for U1 U4 in the row sum matrix U1 U4. First you have to go for the first one U1 college. First you have to fix the college. First to discuss about the college. U1 is the college. Out of this one U1 college is for V1 V2 V3 V4 is first row sum is minus 1.8, second row sum is minus 8.2, third row sum is minus 0.8. Second row sum is minus 8.2. The U1 course U1 college minus 0.8. Second row sum is U1 college. The U1 but V4 course is minus 0.4 here. Second row sum is U1 college. The U1 but V4 course is minus 0.4 here. Second row sum is U1 college. Hello. But V4 course is minus 0.4 here. Hello,
Yeah,
madam.
audible, sir.
Hello. Yes, madam. Hello.
Audible only, sir.
Hello,
Yeah,
madam.
audible, sir.
Hello. Please. Yes, madam. Hello.
Audible only, sir.
Hello,
Yeah,
madam.
audible, sir.
Hello. Are you visible this slide, ma'am? Hello.
Yeah, slides also visible, sir. Audible, sir.
Hello. Are you visible moving slide, ma'am?
Yeah, moving. Slides also visible, sir.
Yeah. Hello. Okay. Are you visible moving slide, ma'am?
Yeah, moving. Slides also visible, sir.
Just a minute, ma'am. Hello. Okay. Are you visible moving slide, ma'am?
Yeah, moving. Slides also visible, sir.
Just a minute, ma'am. Hello. Okay. Are you visible moving slide, ma'am?
Yeah, moving. Slides also visible, sir.
Just a minute, ma'am. Hello. Okay. Are you visible moving slide, ma'am?
Yeah, moving. Slides also visible.
Yes, once you finding the row sum, see that in the yes, once you finding the you can see that in this one in the sum. First you have to fix the college. U1. You can see that in that one which course is better. That is V1, V2 or V3 or V4. Then which one is the highest row sum for better? That is V1, V2 or V3 in the U1 college, it is the fourth course is the best in the U1 college. U1 college, that's but the question arises here. What about the next? Suppose V1 course. It is the question, but is also in the U1 college. V1 course and V3 course are similar because it is minus 1.8. It is also minus 1.8. If they are same terms, how to choose that? Minus the question. If they are same terms, choose that one. Here, means got the that U1 V4 got the highest row sum and V1 and V3 got the same row rank. This can also be seen in the figure 2. In figure 2, consider the curve regarding the element U1. That is U1 V1, U1 V2, U1 V3 and U1 V4. That is the figure 2. This is it. In that cases, again see that these two are same. Then again in the resultants graph also these two are same. That is the first one. That the resultants graph also that is two are same. That is the first one. That the resultants graph also in figure that is U1 U3. These two are same. But in one that U1 V1. But U1 V1, U2 V2, U1 V3 and U1 V4. The highest peak point is this one U1 V4 here. U1 V4. The highest peak point this one V1 V4. This is the peak one. No doubt this is the best choice. But among also in other two cases in the U1 college these only have the same rank. In other two cases in V1 as well as in V3 here. In V3 U1 V1 and U1 V3 are at the same rank. We can analyze the parameter graph. In the parameter, the staircase conclude which is the best here. We can analyze in figure one, we can see that which is the maximum value corresponding to the parameter E4. So between V1 and V3 and means again here it is the same is there. But if again in the resultant graph it is again same is there, then you go for the parameter graph. In the parameter graph, this is the peak here. Go for the parameter. This one is the peak value here. That is V1, V3. In that peak value, this one is the peak value. That is calculate that a graph in one. In that cases, U1 U3 are at the same height. We can analyze that paragraph, that parameter graph, same rank is to calculate. But that is the parameter. Then we can see the figure one. That is U1 V3, which is the maximum value corresponding to the parameter E4. So between the two parameter in the same college, U1 college, there are two courses have the same rank V1 and V3, but by the parameter graph, in the resultant graph again they are same. But in the parameter graph, if you go for parameter graph, this V3 is the peak, for it is the highest for compared to the V1 peak value. Therefore, V3 is our choice here. First it is okay in the first U1 college, U1 V4 is the our first point. Suppose if they are in some problems, if their coincide is there, we can go for the parameter graph as well as the resultant graph here, that is figure 1 and figure 2. And if you prefer E3 or U4, then U1 V1 reaches the maximum peak. So in that case, U1 will be the better choice here. In the same way, we can see that the course V4 is a better choice among all the colleges here. That is here, Rosa. Rosa, V4, that is 23 point among all the colleges. Here also V4, Rosa, V4, that best college. Here also V4 for the second college. V4 it is also the college, and in the U4 also it is. That is V4. It is the point 4. Therefore, in among all the colleges, it is the point 4. Better colleges is among all the colleges this one. Calcutta for the college is the best choice. Better colleges is this is among all the colleges this one. Calcutta for the college is the best choice. Suppose in other aspect, choose the better college for a particular case. Vice versa. Here we have other college. We have fixed the college and courses we are there. We have to choose the best courses one. From among all these, in the all the colleges, U1, U2, U3, U4, therefore the fourth parameter. Fourth parameter is the best course. That is V4. It is the best course for that college is here. It is first you fix the college, then you go for the courses here. Suppose if the Mr. wants, the candidate wants to choose the better college for a particular course. The candidate wants, first he choose the courses. Better college for a particular course. This is my favorite course. I want first choose the college. In which college this course is better. In that case, the particular course you have to fix the courses BI, and then you go for the where is the college. In that case, from the resultant matrix, and then you go from the resultant matrix, see that the row sum. In that, which one is the college? That is matrix. In that the row sum. In that, which one is the college? That is in this one. From the resultant graph, in that which one is the college? That is in this one. To choose the particular course. In that cases, you can see that U1 V4. Choose the particular course. In that U1 V4. You can see that U1 V4. That is the point 4. With the highest row sum and V1 and V3 got V4. It is also. Then for the course, in this case V1. For the course V1, we can choose the course V1. First one is the U3 V1 has the highest row sum because U1 V1 with respect to the course V1. U3 V1. Where is the V1? That is U1 in first row V1 as well as in the fifth row. Where is the V1? That is U1 in first row V1 as well as in the further college. V1 is fixed. Then in the college V1 is minus 1.8 and V1 is fixed. It is in the second college is minus that 3.2 and course is fixed there V1. For the third college it is 7.8 and it is V1 in the fourth college it is minus 0.6. Among these three, the U2 college is the high. That is V1 college is the highest. That is that course is best in which college is there? That is in the U3 college. That is that course is best in which college is there? Yeah. That is in the V3 is the best choice for the V1 course. In the same way, we can conclude that V3 is the best choice for V4, V2, V3 and V4. The colleges in 3 is the best. See that for U2 also. In the U2, in the R2 row, as well as in the R6 row, in the R10 row, as well as in the R14 row, which are the U3 is the best choice here. Again here, some sometimes the values may be same comes, row sum may be same comes. From that one, you can go for the resultant graph. We can choose which is the best by seeing the highest peak and worst pair by seeking the lowest peak. We can also choose the lowest course, lowest in which college is there, and the lowest peak is there. What is the lowest value for the which college in the courses also, vice versa. In that cases, the courses are the worst case. In this, the worst pair by seeing the lowest peak is by the figure U3 and U4. U3 and U4 by the figure U3 and U4. U3 and U4. This is the best. And another one are U4 V2. V4 best V2 and V4 V3. See that in the row sum V4 V3 in that. See that in all the cases row sum V4 courses is the better. In seeing the U1, U2, U3 colleges, V4 is the better course. Similarly, what are the worst cases here? That is V2 and these are least values. V2 and V3 with respect to in the U4 colleges it is minus 9.8, minus 9.8 here. These are the weak courses here. And similarly, if you got the same row sum is there, in such cases it is difficult to decide which is the best by just analyzing the resultant graph here. In that case, you go for the parameter graph that pertains in the result graph here. Which see that U1 V1 and U1 V3 are at the same position. In the resultant graph, that U1 V1, U1 V3, they are the same position in the resultant graph. But from this resultant graph, you cannot come to the conclusion because they have the same peak values. They are in the same position. But in the parameter graph, you can see that U1 V3 reaches a maximum. U1 V3. That is U1 V3 reaches the maximum and that is U1 reaches the maximum value corresponding to the parameter equals so we choose U1 V3 over U1 V1. In that cases we can choose the best colleges. Therefore from the result matrix the 12th row has the highest row sum is there which corresponds to U3 U4. That is the value it is 23.8 inches. The 12th row has the highest row sum which corresponds to the value it is the resultant graph can also decide this by seeing the highest peak U3 U4 highest peak point. See that in the resultant graph U3 U4 this is the highest peak point in the 12th row. In that one this is the highest peak point. If suppose if there are two are all the same position is there, then we go for the resultant that parameter graph. But in the parameter graph, in the resultant matrix graph, this is the peak point. Therefore, in among all these conclusions, this is the best college and in the course here. The result can also decide by the peak, which corresponds to U3. So U4 is the course best in U3 college. So U4, the problem with the relates to elements of both the means in that case we are relating what? With respect to the parameters also, degree of belongingness and to college and courses here. Means here college you have to check first college and courses. Then you have to in that college which course is best. Suppose in the first college is there, U1 college is there, which one is the best? By analyzing the row sum matrix. Means U1 is fixed. Then U1 is there, then U2. There are 16 row sum are there. Out of that one, fix the college. U1. Then course is what? In which college? U1, P1, U2. What is their other courses and other courses? Which one is the highest peak one? Similarly, what is their other courses? The course. Then you can choose the college. In which college? Our choose course is best. Is better in which college we want to study. For that, we have to fix the course. Then we have to go for the college. Similarly, if there is in a row some values coincides, they give the same solution. solution is there. First, let's see the resultant matrix, which graph, which coordinate point, U3, U4 or U1, U2 or whether U4, U2, which reaches the which one is reaches the highest peak point. That the our best choice here. Suppose in the same peak point is there for in the resultant matrix, then you go for the parameter graph. In the parameter graph, we can see that which one is the peak one. That we can also parameter graph. Suppose in some situations also, in from our problem we can say that in the parameter graph also, both the values are same terms, we can choose. It is decided by the parameter candidates here. In the U1 college, P1 and U2 college also U1 is there. In that cases, it is the candidate I can choose. But if possible, in that case, to see the graph, which one is the peak point, but then we can choose the that one here. Therefore, here this method relates with elements of both the universal sets with respect to the parameter and gives the result means college, which college this course is best and which course is best in the which college here. This is the method for finding the solutions of an college, choosing the method for courses here. It means if the candidate has the two universal sets is there, means in the problem he has the two universal sets is there with respect to parameter set is there. This fuzzy binary subsets is best suitable to solve this one. This is the first attempt using applying the fuzzy binary subsets here. That the conclusion is what that discuss the problem involving two universal sets and a parameter set that assigns the members of values to universal set. This method can solve a problem involving two universal sets that wants to a simultaneous solution. Means for college, fix the college and course, or course fix and college. The both simultaneously can find us. This method can apply for a parameter set that contains a finite number of parameters. If two rows got the same row sum, then we can conclude by plotting the parameter graph here. This is the our conclusion, and these are the references. And binary subset is by n thus n, and these are the some references, and these are the some references. Yes. Thank you. Some references. Yes. Thank you. Yes.
Thank you, sir.
Any doubts is there? Any questions? Thank you. Yes.
Participants, if you have any questions, you can ask.
Is there any questions? Thank you. Yes.
Participants, if you have any questions, you can ask.
Is there any questions?
Question session.
Thank you. Yes.
Please ask your. If you have any questions, you can ask.
Is there any questions?
Question session.
Thank you. Yes.
Please ask your. If you have any questions, you can ask.
Is there any questions?
Question session.
Thank you. Yes.
Please ask your. If you have any questions, you can ask. Question session.
Okay.
Please ask your.
Sir, you said.
Sir, good afternoon, sir.
Question session.
Yes, sir. Good afternoon, sir. Madam, please.
Sir, you said.
Sir, good afternoon, sir.
Question session.
Yes, sir.
Sir,
Good afternoon,
using
sir.
this
Madam, please.
binary fuzzy topological set, if we take two
Ask
universal set
topological
U
set,
and
madam,
V,
please. Don't mention the topological set.
if
Yeah.
we take two universal set using this model, if we take two universal set U and V, U
Yeah,
and V,
yes.
let U be a diabetic patient and V be a thyroid patient.
Yes, okay. Yes.
Can the doctor give the final recommendation for their disease using their parameter like symptoms of the disease?
Yes, yes, yes. You can apply the same thing. We are also working on that. We have already finalized in the general problem. If there are two universals with the parameter is there, data is available, you can apply this problem. If there are two universals with the parameter is there,
It is possible.
yeah, you can apply that.
Yes.
Because in the earlier method, there are only one universal set. Yeah. But here,
Yes,
we are
sir. Yes, sir.
considering the two universal sets. There are only one universal set.
Okay, sir. Okay,
But
sir.
here,
Okay,
we are
sir. Thank you,
considering the
sir.
two
Thank you.
universal sets. One universal set.
Okay, sir. Okay.
Sir, in this paper you are using matrix, right?
Yes, madam, please.
Okay.
Yes, sir. Can we apply the same matrix properties for this
Yes, madam,
fuzzy
please.
subsets? Yes, sir. Can we apply the same matrix properties for this
Yes, madam,
fuzzy
please.
subsets? Yes, sir. Can we apply the please on matrix properties on your microphone, sir? Your voice is not.
Yeah, yeah.
Can we apply the
Yeah,
please
okay.
on On your microphone. Matrix properties we have no, sir. The properties, can we apply the same properties for this properties we have no, sir? The properties,
The matrix
can we apply
property.
the same properties for this properties we have no,
But what happens here?
properties,
The matrix property. In the matrix form, there are certain, there must be a square matrices. But here we are considering the core. But if you go for this eigenvalues and eigenvectors, you can also further studies also there. But if you can apply the property, no problem. Further studies also there. But if you can apply the property, no problem.
suppose if it is not a square matrix, suppose if it is a rectangular matrix, suppose if it is not a square matrix, suppose
If it is rectangular matrix, again we go for the row sum matrix only. It is.
not a square matrix, suppose
Because in the some situation, if you go for the properties of the matrices, it is sometimes it is a square matrix. It is essential. But in this case, it may be square or may not be square. Matrix it is essential. But in this case, if it is square comes square, no doubt it must be a skew symmetric matrix. But in this case, if it is square comes square, no doubt it must be a skew symmetric matrix. But in this case,
so can we derive
no doubt it must be a
topological sets from fuzzy subsets?
yes, no, so you can define.
Topological sets from
Already it is there, no? Fuzzy sub topology. Yes, no, so you can define.
Topological sets from
Already it is there. Fuzzy subset is there. Binary sub topology is there.
topological sets.
Yes, you can apply the topology. This is what using the sets how you can solve the real life problem. This is what using the sets how you can solve the real life problem.
Participants, any other questions you have? Please ask.
Real life problem.
Participants, any other questions you have? Please ask.
Real life problem.
Participants,
It is
any
a
other
simple
questions
one.
you have?
Those who are entry level in the PhD, it is helpful for them to how to solve the FEM problem. This is an idea. One simple idea. It is helpful for them to how to solve the FEM problem. This is an idea. One simple idea. It is helpful for them to how to solve the FEM problem. This is an idea. One simple idea. It is helpful for them.
Thank you, sir. Respected Chief Guest and esteemed faculty members, we are grateful for the enlightening mathematics session we had today. Your presence and participation made it a truly enriching experience. A special word of appreciation to our Chief Guest and participation for taking time to share valuable insights with us. Your expertise and passion for mathematics inspire us all. We also extend our thanks to our organizers and volunteers who are tirelessly to this event a success. Thank you once again, and we look forward to more engaging sessions in future. Thank you, a success. Thank you once again, and we look forward to more engaging sessions in future. Thank you, a success.
Thank you, sir. Sir, can you share the PPT to us?
Thank you. Okay, no problem.
Okay,
I will share the
can
PPT.
you share the PPT
By
to
WhatsApp,
us?
by WhatsApp or mail.
By WhatsApp or mail?
I will share the
Can you
PPT. Mail you
share
can.
the
Yes, by
PPT to
WhatsApp I will
us?
send. By WhatsApp or mail.
By WhatsApp or thank you, sir. Thank you so much.
Thank you very much. Once again, thanks for the organizers for giving me an opportunity to share my ideas here. Thank you, one and all. Organizers for giving me an opportunity to share my ideas.
Participants, now you can move for lunch. By 2 o'clock, we can start the next session. Now you can, we'll send the feedback link. By 2 o'clock, we can start the next comment box. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Comment box. Thank you. You can fill the second session feedback. By 2 o'clock, we can we'll meet by 2 o'clock. Participants, kindly fill the feedback link for the second session for Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session for Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session for Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session for Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session for Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session. Dr. P.G. Patel, Karnataka University. Fill the feedback link for the second session.